Good evening, my dear JEE warriors. Welcome to the world of optics. It's a very high weighted chapter for your JEE mains as well as JEE advanced, and guaranteed one question. And there is a very good chance you might get even two to up to three questions depending on which exam you're writing. So a lot of amazing, interesting things are there with optics and lot of applications, especially on optics in your day-to-day life. And what I love the most is the optical illusions, like the one over here. I'm pretty sure if you concentrate on this image, probably you might be seeing as if these square circles, the circles made of squares are, looking entangled. But what if I told you actually they are not, but they are actually discrete, separate circles? So that's the world of optical illusions, and it's very interesting to see these phenomena, see these tricks in real life too. And this also tells you how your brain is probably fooling you right now. You might think that it is something, but actually it is something else. And this optical illusion exactly says that. So let's begin with this chapter of ray optics. I'll be dividing it into two parts. This is part one today, where I tend to complete mirrors, both curved and flat, and then refraction on the plane surface. This is what I intend to complete. Hopefully we'll be also able to complete the prisms part, which is a part of, or you can say, refraction at a plane surface. All right, so this is what we intend to complete in the part one, and in the part two we will do lenses, curved surface refraction, combination of lenses, silvering of lenses, and the optical instruments, all those things. That is how we have divided these lectures. So let's begin with me, your captain Shreyas, your physics master teacher, and let's get going. And before we proceed ahead, you know what to do, the usual ritual: smash the like button right now. Yep. There will be advanced questions, everything, all the kind of questions we do over here. Those of you who are new to the series, let me remind you, this is your ROAR series. In ROAR, we have three levels of questions: basic one, then the intermediate is basically your mains level, and the next level is advanced. So it's a combination of all the three levels, and of course, you should understand this very simply. Whenever we start from the scratch, we'll try to complete as many questions, applications as possible. And like I said, after the entire syllabus completion, we will have mainly practice sessions, problem solving sessions. That is what we are going to do. Is that okay? All right, rock shows, Marshall's Law, hello Renault, Tomato, wow. And Avanishri, hello Vishal, hello Dharnishwaran. How many hours lectures? This will be around 4 to 5 hours. Okay, expected to go around 8:30 or 8 o'clock, around that time. All right, so let's begin. Starting off with some basic terminology, really quick. See, this chapter deals with mainly reflection and refraction of different objects, different phenomena which we study. So, if light is, hitting something or entering something, one of the two might happen. Either it will bounce back or it will pass through. Either it will bounce back, reflect, or it will pass, and that passing is called as refraction. Basically, it goes from one kind of medium to the other medium. So if the light ray is bouncing back, it is reflected ray. If it is going to the other medium, it is called as the refracted ray. The rays of, or the beam of light which is falling onto the surface or on that object is called as the incident. So incident, reflected, and refracted is the most commonly used terms in this chapter. Another common term which you should be aware of before we begin is parallel beam, divergent beam, and convergent beam. See, when I say parallel beam of light, it means the rays are obviously parallel, they are not intersecting. Divergent or convergent means the rays are intersecting. Okay, the rays are intersecting, like for example, your headlight, all right, or probably your projector screen. The rays are converging somewhere, right? So you will see that the rays will intersect. If they are going far away, it is divergent. If they are meeting at a place somewhere, it is called as convergent beam. As straightforward as that. Next thing which you should be aware of, something called as the real image or the virtual image. Okay, so real image is something like, seeing a movie in the theater. The movie which you are seeing on that screen, that is actually a real image, because you will see behind you there is a projector, light is coming from the projector, the rays are meeting at a place, Basically, it's a convergent beam. So if it is a convergent beam and the rays meet at a point, that point you say real image is formed, and to see that real image you use a screen. Best example, movie projector. Okay, so that is basically called as a real image. Basically, you need a screen for that. Usually you use it, see it using a screen. The next type is virtual. Like for example, your mirror. Okay, you can see it through your own eyes. If you are standing in front of the mirror, what you see is a virtual image. Basically, the rays appear to converge at that point, but actually they don't converge. Think of it that way. They don't actually intersect in case of virtual. In case of real, they actually end up intersecting. The best way to show that is something like this, by drawing simple ray diagrams. Say for example, the rays are meeting like this. So this is the point of your real image, and it can be obtained on the screen. This particular real image, it can be obtained on the screen, whereas over here, in case of virtual, you should understand the rays appear to come from a point. They are not actually meeting. They appear to come from a particular point. So that is basically your virtual image. As simple as that. They don't really intersect. They appear to come from a particular point. Yep. Good evening, Mesu. Hello, Dream. Is this class 12th physics chapter? Yes. Hi, Harburain. Nice to see you back. Okay. Now there is also something called as real object versus virtual object. Usually you deal with real objects, but you can also have virtual objects. Real objects means very simple. Right now I am a real object, obviously, because you can see that the rays fall on me, light rays fall on me, and they are reflecting in different directions. It feels as if the rays are coming out of me. So that's a real object. The rays originate actually from a point. Virtual object, you might have seen some sci-fi movies where there is a hologram, where you feel that the person is there, but when you put your hand, nothing, nobody to feel, nobody to touch. So that is a virtual object, where the rays appear to meet at a point. That is a virtual object. Now, for now, just remember, real means actual, virtual means appear to. Real means actually they intersect, virtual means appear to intersect. That is the major distinction between the two. When we solve problems, you will be easily able to see in concave, convex mirrors or lenses how to distinguish between the two. Okay, we'll be dealing with plane mirrors, concave mirrors, etc. Then it will become very straightforward. Okay, so this we had done already. So let's probably do some questions based on this standard basic terminologies. This is like a warm-up for the main chapter. Can you really photograph a virtual image? That's the question. Yep. Come on. Yes. What is incident ray? Yes, incident ray is basically the ray which actually falls on anything. Can you photograph a virtual image? Remember, virtual means the rays appear to come from some point. This is a virtual image. Can you photograph it? The answer is of course yes. Why not? Anything which you can see, you can photograph it. Even real images can be they can be photographed. Best example, have you heard of the term mirror selfie? Have you taken a mirror selfie? That is the best example. Definitely, you can. What do you see in the mirror? A virtual image of yourself. The rays appear to come from behind the mirror. Remember that. The rays appear to come. So your mirror is technically over here. This is the mirror. The rays appear to come from behind the mirror. There is a virtual image. You can take a camera, a mobile camera, actual camera, whatever. and you can photograph it. Definitely you can. You can even photograph a real image. That's how movie piracy happens. Somebody takes a recorder in the movie theater and records the entire movie and later on leaks it on some torrents or something. So you're recording a real image. So both images can be photographed. As simple as that. Okay. If more rays are going to meet at a point, then what happens to the image? And when the rays, when they form an image, they don't meet at the same point, then what happens to the image? This is another very, very interesting question. Okay, Dharneshwaran, I hope this is clear now to what exactly happens. Now remember, in order to form an image like we said before over here, just going back a little bit, whether it is real or virtual, remember, you need a point of intersection. Remember, you always need something called as a point of intersection. Whenever you want the point of intersection, how many rays you need? At least one line can't intersect with itself. You at least need two lines to intersect. So minimum two rays are needed. Minimum two rays are always needed to form the image. To form the image. To form any kind of image, what you always need is basically minimum two rays. That means over here, imagine there is one ray like this, another ray like this, and one more ray is intersecting at the same point versus just these two rays. Or imagine there are more rays over here. There are more rays over here, they are meeting over here. Here also image is formed, here also image is formed, just that this will be dim, whereas this will be more bright, because more rays means the light's intensity will be higher. That's it. So the image will get brighter. The image will get brighter. That's the only difference. Correct. Is that very, very clear, my dear warriors? Is that clear, my dear warriors? Very good. Awesome. 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 Next important thing is, what if the rays which are meeting are not meeting at the same point? This is interesting. Imagine instead of all these rays meeting at the same point, one ray is meeting here, another ray is meeting here, another ray is meeting here, another ray is meeting somewhere here, okay, or meeting somewhere like this. Then what will happen? There is no clear-cut point where the image is formed. In such a case, no clear picture. So the image is not clear. The image is not clear. Basically, it becomes blurred. Basically, it becomes blurred. Very good. Excellent. So more the rays, better it is, but they should all meet at the same point. Otherwise, the image becomes blurred. Awesome. So now that you understood the basics, let's begin with reflection. And to begin with reflection, I hope you have smashed the like button right away, right now. Yep, do that. That's your Guru Dakshina for attending every single class. Yes, Dhanashri. Yes, Dhaneshwaran. No clear picture. Correct. Let's begin. Okay. Now in reflection, we are going to study both kinds of reflection. We'll start with plane surface, then we'll go to curved surface, which is concave convex mirrors. Now I know a lot of people skip plane mirrors completely, thinking it is not there in the syllabus, but you will see it has been asked in JEE Advanced as well as many other competitive exams. Sometimes people think it is deleted, but guys, it is definitely not advisable. All right. So when we talk about a reflection, when a ray falls on a reflecting or a silvered surface. Why silvered? Silver, when you take a glass and silver it, it acts like a very good reflector. That is what basically a mirror is. So all the light which falls onto it gets reflected back. So that is a mirror. And then you will see, if you draw a perpendicular to the mirror surface, the light which falls, the light which bounces back, and the perpendicular, all of them are going to be in the same plane. Very, very important. They are going to be in the same plane. It's not like, incident ray is here, normal is here, reflected comes out of the board plane. No, it is in the same plane. That is very, very crucial. All right. Next important point is this particular angle of incidence and this particular angle of reflection, both of them are always going to be equal. This angle of incidence and this angle of reflection are always going to be equal. Is that clear, my dear warriors? Is that clear, my dear warriors? Okay, very, very straightforward. All right, moving on to this next concept. Now that we know that angle of incidence is always equal to angle of reflection, next important point is they are always going to be in the same plane. You can also write it in the vector form. I think I had put it in the slides somewhere. Yes, right over here. Because if this is the mirror, this is the reflecting surface, and this is incident, this is reflected. Say for example, this is angle of incidence, this is angle of reflection. And now just imagine I call this normal as a vector n bar. I call this incident ray as a vector I bar and this reflected ray as a vector R bar. Because they are going to be in the same plane, because they are going to be coplanar, then there is something called as the scalar triple product. The scalar triple product is always going to be 0 for any three coplanar vectors. Keep this in mind. Yes, it is always going to be 0. What is scalar triple product? Can you guess, guys? Yes, come on, tell me. What do you think is scalar triple product? Think about it. Scalar, the answer should be a scalar form. Yep. The answer should be a scalar. Yes. And triple means it should have 3 terms in it. Correct. So, hence, you will see that I vector, then if you take R vector, and then if you take normal vector, if you take cross product, put dot product over here like this, the answer will be 0. Now, it doesn't matter in which order you go about it. You can also write R bar dot N cross I. Doesn't matter. The answer is always 0. No matter what you keep outside. You can also put N bar outside and you put dot product I cross R. Answer will be a big fat 0. Keep this in mind. Yes. So scalar means answer should be a scalar. Triple means there should be 3 things. But don't think it is dot and dot together, because if I put a dot here, then what happens is this vector dot this vector will become a scalar number. I cannot take a scalar product with a vector on one side and a scalar on the other side. That's why to preserve the vector, remember, this has to be a vector quantity, because when I put a dot, both sides should be a vector, or else it will be mathematically incorrect. So don't say it is A dot B dot C, it is A dot B cross C or A cross B dot C, one and the same thing. Correct. So this is always going to be 0. You will also see that the ray which falls ideally wanted to go along this particular path, but it also will get deviated by some amount. It will also deviate, like you wanted to sit and study today, but because you got a mobile notification, suddenly you got deviated and you turned your attention away from the classroom and now you are texting or talking to your friend. So that is deviation. You are deviating from the intended path. So look at this. This was the incident ray. This was the incident angle, which is I. This was the reflected ray. The reflected ray angle will also be equal to I only. And then you will see that the ray which was intended to go like this is finally going over here. Hence, this particular angle is the angle of deviation. Obviously, the sum of all these angles is going to be 180. I plus R plus delta is 180. So therefore, delta is 180 minus I minus R. Therefore, delta is equal to 180 minus 2I, because I and R both are equal. equal. That's the logic behind it. Remember, I and R are always measured with normal, not with respect to the any other line or any other plane. Yes, keep that in mind. It is always measured with respect to the normal. Great. Keep these things in mind. Probably we can solve some questions based on this. Okay, very interesting question coming up. Two vertical plane mirrors are inclined at an angle of 60 degrees with each other. A ray of light which travels horizontally is reflected from one mirror and then from the other. The resultant deviation is how much? Okay, let me draw two mirrors which are inclined at 60 degrees with respect to each other. They are inclined with respect to each other at 60 degrees. What happens is a ray of light which is traveling horizontally is reflected from one and then from the other. Then what is the resultant deviation? If this ray comes like this, if this ray comes like this, and if I draw a normal over here, if I draw a normal over here, okay, it will get reflected like this. It will basically get reflected like this. If this is 60 degree, naturally, even this angle, because two parallel lines, the angles are same. So this is also 60 degree. That means this is basically 30 degree. So is this angle also 30 degree. If this is 30 degree, that means this particular angle over here, is also 60 degree. So now this ray will continue its journey and hit this particular surface. If this is 60, this is 60, it is obvious that this internal angle is also 60 degree. Now it will hit this surface at an angle of incidence of again 30 degree. So this will be also 30 degree. It will also rebound at again 30 degree and it will go back like this. And obviously now it will be parallel to this particular surface. Now it will be parallel to this particular mirror surface. So the question is, what is the resultant deviation? Well, in order to find the total deviation, I will do delta 1 plus delta 2. What is delta 1? It is nothing but 180 minus 2i, but the first time, plus 180 minus 2 angle of incidence the second time. So what is the angle of incidence the first time? It is 30 degrees. So 2 into 30 plus 180 minus, what is the angle of incidence second time? It is 30 degree. So 2 into 30 degree. So guys, what is 230? 2 into 30, 60. 180 minus 60 is 120. So 120 plus 120, which is 240 degrees, which is the D option, IIT Delhi. That is correct. No, it is not option A. It is option number D. It is option number D. Cool. Understood? Oh, clear? Oh, can we go ahead? Very, very interesting question. You had to do it using geometry. You will see that in this particular chapter, most of the times you will have to use some kind of geometry to solve the question. Okay, and this is exactly what this is. This question is not there. What do you mean by not there in Tattva book? Means it will be there in some other form. It will be there in some other form. Which of what should be the angle between the two plane mirrors, so that whatever be the angle of incidence, the incident ray and the reflected ray from the two mirrors will be parallel to each other. Good evening, Adiksha. What will be the angle between the two mirrors so that no matter what, the rays are going to be parallel to each other? So just imagine this. This is your mirror. Okay, this is a mirror. I don't know what the angle between the two mirrors is going to be, but whatever ray falls, reflects, and then reflects, it should go and come back like this. This is what should happen. And I can draw normal over here, I can draw normal over here, and we all know this angle should be equal to this angle should be equal to this angle, and these are two parallel lines. These are two parallel lines. So a lot of angles will be congruent. Just think which of these options will match. Which of these options will match this particular given set of problem. Just think about it. Just think about it, guys. And this is a completely symmetric scenario. Whether you incident on this and then reflect it over here, or incident on this and reflect it over here, it's going to be one and the same thing. Come on, will it happen at 60, 120, 175 or 90 degree? See, the answer won't be 175 or 120. Most likely either it will be 60 or 90. By common sense, it has to be something very good angle because the rays are parallel to each other. Just think about it. What if I do 90 degrees? If I hold the mirrors 90 degrees perpendicular to each other, then what will happen is, if the ray comes over here, reflects and then reflects, I feel they must be parallel to each other, and I can just prove it to you over here very easily. See guys, this angle will be complementary to this angle. This angle will be equal to this angle, and this angle will be equal to this angle, because if this is 30, this will be 60. If this is 60, this will be also 60. If this is 60, this will be 30. So 30, 60, 60, 30. That is how it will be. Now, if this is 30, this is 90, obviously this will be 60. That means it will be complementary of this. So this will be cross. If this is cross, this will be like this. If this is the complementary of this, angle of incidence will be angle of reflection, and this will be basically cross. Now you will notice that these two parallel lines which are there, now you will notice these two parallel lines which are there, these two parallel lines which are there, this is basically an intercept. This is basically an intercept right over here. Okay, you can even take these two parallel lines. You can even take these two parallel lines. You can see that this is an intercept over here. Okay, and you can see very clearly this angle and this angle are equal. This is like saying these two lines are there. This is there over here. You can clearly see an angle which is over here and the angle which is over here are equal. This angle, they are equal. So they are parallel to each other. Only then this can happen. Only then this can happen. All these intercepts are going to be equal. Only then this can happen. Just look at this. Everybody can see these two lines and these two lines. Yes, you can see that. So I think it should be 90 degrees. Correct? Very good. If you wrote answer as 90 degrees, proud of you. Answer is D. For no other angle, this can happen. For no other angle, this can happen. You can also see one more set of parallel lines over here and over here. You can see this angle, right? This angle over here and this angle. They both are making the same angle with the horizontal. This and this cross and cross with the horizontal, they are making the same angle. So these two lines must be parallel. So when the mirrors are inclined at 90 degree. Great, awesome. Now comes the next part where we take some more special cases for plane mirrors, where you take a mirror and rotate the mirror or rotate the incident angle. What changes does it have? The first case, these kind of questions are also very common, by the way. First case is where you have a mirror, and this is our incident ray. This is our incident ray falling in like this. It will rebound back like this. It will rebound back like this. Obviously, this angle must be exactly equal to this angle. If the incident ray is rotated by some angle keeping the mirror fixed, the reflected ray also rotates by the same angle. Kind of makes sense. Just think about it. If now the ray is falling like this, I have increased the angle of incidence by theta. What will happen to the reflected ray? The reflected ray will also increase the angle by theta, which kind of makes sense. It looks very obvious over here. To preserve angle of incidence equal to the angle of reflection, the amount should be the same. So theta is equal to theta, assuming the mirror is fixed. Assuming the mirror is fixed. If the concept is clear, can we solve every question? Heroic? No. If the concept is clear, you cannot solve every question because you need practice, and concept clearing is not just about remembering the theory or applying the formula at that point. It has to click that you have to use the concept. It has to click what mathematics has to work. You cannot make any silly mistakes. You have to complete it in the given time frame. So there are a lot of things for solving a problem. It's not just knowing the theory. The second special case is when the mirror is rotated whereas the ray is fixed. I have a very interesting proof for the same to what happens to the reflected ray. Look at this. Imagine this was the incident ray, this was the reflected ray, like this. So now I want to rotate the mirror by some angle. So instead of rotating the mirror by that particular angle, what I will do this in steps. How? Observe. Observe. I am going to just take the mirror as it is. I am just going to draw the new ray which is incident, but it is making an extra angle of theta with respect to the original incident ray. With respect to the original incident ray. With respect to the original incident ray. I will make this orange line fall on the yellow line. To make the orange line fall on the yellow line means I have to rotate the mirror by how much? I have to rotate the mirror by theta. So now the next step will be now rotate the mirror by theta. Now rotate the mirror by theta angle. See what will happen? The orange line will fall on the yellow line. Okay, let us see what exactly happens. The mirror is now rotated by theta. Obviously, this normal will also rotate by theta. So now your yellow line and that particular orange line, both of them are falling on the same uh, line. Yes, both these rays are now together. So what will happen to the orange one? Because I'm rotating the mirror by theta, even the orange one will rotate by theta. Even the orange reflected right will rotate by theta. Is that right? But remember, the original orange line had already rotated by theta. Now you further rotate by theta. So what is the total angle by which the reflected ray has rotated? By 2 theta. I hope that made sense. So initially the light which fell was reflected here. So if I increase this, the orange line is now making an extra angle theta. If I bring it back, it has further rotated by theta. So with respect to the original ray, it has rotated by 2 theta. With respect to the original ray, it has rotated by 2 theta. So if the mirror rotates by theta, the final reflected ray rotates by 2 theta. The final reflected ray rotates by 2 theta. Okay. I hope this is absolutely very clear. Cool. Let's solve some questions coming up on your screen. Here is the question. Let's see if you can solve it. Some of you are asking, sir, which book should I solve? There are 2 things which you should solve. Number 1 is, as you are watching this lecture, in the description there is something called as Jungle Book, where I upload the PPTs. Any video you take, okay, in the description of the video, you will see something called as a Jungle Book. This Jungle Book has basically all the PDFs uploaded of the notes, the chapter names are given, and the DPPs are there. This is the first thing which you will solve. Okay, this is number 1 thing. Another thing apart from the Jungle Book which you will be solving is basically the Tattva module. This Tattva module books, you will get it at your doorstep. It's a collection of 20 plus books, physics, chemistry, maths included. It has solved examples, level 1, level 2, level 3. If you solve this book, 100% guaranteed. 100% guaranteed, guys. You don't need any other book. Okay, where do you buy this book? Again, this link is there in the pinned message of the chats. If you are watching this lecture, you will see in the pinned message of the chats, or even in the description box, buy the best books, some link will be there. The Tattva module, that is what you have to solve. Nothing else you need. Okay, Darsh. All right. What about this question? You can see there are 2 things happening. Incident ray is rotated by 10 and the mirror is rotated by 20. Because the incident ray is rotated inwards by 10, the reflected ray will also rotate by 10 degrees inwards. Number 1. Number 2, this mirror is rotated by 20 degrees like this. So what will happen? The reflected ray will rotate like this by 2 into, remember 2 times theta. So 2 into 20 degrees, which is basically 40 degrees. So the ray ends up rotating 40 degrees this way, 40 degrees this way, and 10 degrees backwards. So the net amount by which it rotates is nothing but 30 degrees in the clockwise direction, in basically the clockwise direction. As simple as that. Hence the answer is option B for IIT Bombay. Exactly. Awesome. Very good, Sadia, if you are having that book. Awesome. Continue practicing. Okay, so this is how you can get these kind of questions on deviation. Okay, now let's go to the next concept of basically reflection by plane mirror. Reflection by plane mirror. Whenever you stand in front of the mirror, you might have seen yourself hundreds, thousands of times. You know what kind of the image you get. Obviously, when you see yourself, it is not a real image. You don't need a screen or anything. It's seen directly through your eye. It feels the rays are coming from something behind of the mirror. So yes, it is a virtual image. You also see that the image is of the same size as of you. It's neither small, nor do you look thin, nor do you look fat, unless the mirror has some bulges or some uneven surfaces. So it is of the same size. There is no magnification. Also, the image is erect, meaning if you're standing like this, it's not like you see the upside down version of you. You see exactly the image standing the same way you are. If you are sleeping, the image is sleeping. If you are sleeping this way, it is sleeping that way. So it is exactly aligned with you, upright. So it is erect, is what you can say. But one thing which what changes is, imagine this person had a pen or some object in the right hand. The object was there in the right hand. For the image, this same object will be there in the left hand of that person. So if I raise my right hand in front of the mirror, my image will raise the left hand. If I raise the left hand for me, the image of mine will raise the right hand. This phenomena is called as the lateral inversion. It's called as the lateral inversion. You can think of it like, probably something like this. Imagine you have a sock. This is your sock. Maybe this sock goes in your left hand. You take this sock and pull it inside out. You pull it inside out. What you get is the laterally inverted image. So lateral inversion is basically taking an object and pulling it inside out. You take it and pull it inside out. So you put your hand in and take it inside out. That is what lateral inversion actually stands for. So imagine somebody, okay, some mystical creature takes their hand, pulls this person inside out. That is what lateral. Somebody pulls me inside out. That is what lateral inversion is. So all these things I've mentioned over here, image is laterally inverted, same size, it's virtual and all of that. Okay. Now there are certain important things which I would like to show over here. Like for example, this is the mirror. If this was the object, you will see as if somebody has pulled the image inside out. It will feel as if somebody has pulled the image inside out. And just see, somebody has pulled the image inside out. That is what lateral inversion is. Now, let me also tell you over here, many times people think that the image is always virtual, but that is not entirely true also. Just imagine there is a mirror. You have an object, the rays go everywhere and they will reflect using the laws of reflection, something like this. You see where these rays meet behind. This is where you will get your virtual image, because the rays are not exactly intersecting. They have to be extended or elongated to make them meet at a point. This is where the rays are actually intersecting. So this is basically a real one. So this is a real object. This is a real object. Now look at this particular scenario. Look at this particular scenario where you have the rays falling from something, maybe the sun, maybe from a telescope, maybe from a magnifying glass. They are falling from some distant object like this, and they appear to meet over here. They appear to meet over here, but they can't meet because the mirror bounces the light off like this, and these rays will end up meeting here. Because they are actually meeting here, actual means real, so there is a real image which is formed, but this time the object is here. This is a virtual object. This is a virtual object, guys. Very, very interesting. So if you take a screen, you need to place it here. You won't see anything inside the mirror, but it will be somewhere over here, guys. It will be somewhere over here. This is where the final image will be formed. So don't think only virtual images are formed by plane mirrors. Even real images can be formed by plane mirrors. Even real images can be formed by plane mirrors. Hello, DJ Tilu. Yep. I hope this is absolutely very, very clear. Having said this, there is some concept called as the field of view concept for a plane mirror, wherein there is only a certain region where you can see the image. Beyond that, you will not be able to see the image. Let me explain this concept with a simple, ray diagram. So let's say you have a mirror like this over here, and let's say you have an object over here. Now the rays from the object will go everywhere. The rays from the object will go everywhere. Let's say one of the rays goes here, then let's say one of the rays goes here, then let's say one of the rays goes here, then let's say one of the rays goes here, and it will also get reflected. So it will follow the laws of reflection. It will follow the laws of reflection, something like this, and it will get reflected at all these places. At all these places, reflection is occurring. The rays are getting reflected. So if you are here, you will see that the image is somewhere here. If you are here, you will see the image is somewhere here, because the rays will eventually enter the human eye. If you are standing here, so this is a Pandu standing here, the rays will enter the human eye, so you will be able to see the image. But what about these rays, which I am about to show? This ray will not be reflected. This ray will not be reflected. This ray, so many rays are there which will not be reflected. Just look at it. It's like the mirror is not there in the path of the light rays. So I would say then this particular region is the field of viewing the image inside the mirror. If I stand somewhere here, probably in this whole region, this is basically going to be a dark zone. This is going to be a dark zone. I won't be able to see the image. If I stand here, or if I stand here, I won't see any reflected light ray from the mirror. I will directly see the original rays. So this is the dark zone, or blind spot, or I can also call it as the blind spot, because I can't see the image inside the mirror. I hope this is absolutely very clear. Very good. Awesome. Shall we go ahead? My dear warriors? Yes. Great. Now, this field of view will play a very, very important role in determining how much of the image you can see, where and all can you see the image, how much mirror you need to see the image, and all of that. Like say for example, imagine there is a tall elephant over here, or a tall tree over here, and I want to see that. And let's say our Pandu is over here, or Pandu is here, and let's say the mirror is somewhere over here. It could be anywhere, guys. So just 1 second. Let's say this is our Pandu. Let's say this is the mirror. I want to find out how much of the mirror is needed for me to see the Pandu. Sorry, to see the elephant. How much of the mirror is needed by Pandu to see the particular elephant or the tree? Because I won't need the big mirror. Maybe a certain size of the mirror is enough. In order to solve those kind of problems, what you need to do is as follows. Observe this very carefully. Just imagine an infinitely long mirror for now. Just imagine an infinitely long mirror as of now. We'll assume we need a very long mirror. But maybe I will see most of the part of the mirror will not be needed when I draw the proper ray diagram. I want to see the complete object, the tree, the elephant, whatever it is. And here is where I am. So the rays should finally enter my eyes. So what I will do is visualize the same object behind the mirror at the exact same distance. Visualize this particular object, whatever is there in front of the mirror, exactly behind the mirror. So if this is basically X, assume this is also X, and imagine that same object over here. Now, think of the mirror as a window into the virtual world. You might have seen some scary movies where ghosts come out from the mirror, or a person goes inside the mirror and gets trapped. You know, such scary stories are there. So just imagine this window or this mirror is like a window into the virtual world. Imagine this elephant or this tree has gone into this virtual world. You are still trapped in the real world. Or I won't say trapped, you're still thankfully in the real world. Now just imagine you have to see this elephant. How will the rays from that elephant travel basically? So essentially, the rays will travel like this into the eyes of Pandu. The rays will travel like this into the eyes of Pandu. These are the extreme rays. All other rays will obviously travel into the eyes of Pandu like this. This is how it will go. Right? That means only this much portion of the mirror is needed. That means exactly from here to here, exactly that much portion of the mirror is only needed. This is the mirror which is needed. What I don't need is that extra part here. This is not needed only. Even if this was not there, the rays are not going through. The rays are not going through. So I don't need this, nor do I need this. Actually, what has happened is the rays did not come from here. Actually, they came from here only. It's just that they got reflected. That's all. It's just that they got reflected. They came here, reflected. They came here, they got reflected. They probably came from here, they got reflected. They came from here, they got reflected. They came from here and they got reflected. That's all that has happened. So actually speaking, the rays have come like this. The rays have come like this. The rays have come like this. It's just got reflected at these places. I don't need this extra part of the mirror. That's how you find the size of the mirror which is required. After this, it is pure geometry. After this, it is pure geometry. I hope this is very, very clear. Amit, I'm very good. Okay, so these are very important concepts regarding the field of view, where you might have some blind spot related question, or where is the image seen, which all places, or you can alternatively have how much of the mirror is needed to see that particular object. It could be yourself, it could be somebody else. Use simple geometry. In all these problems, generally you will use the properties of similar triangles. I hope you can see there is a small triangle here and there is a big triangle here. Can you see those two triangles? So usually you use those properties. Usually you will use those properties, guys. That's all usually what you will need. One triangle over here and probably another large another large triangle over here. So these triangles are basically similar triangles, and that also implies sides are in the same ratio. Sides are in same ratio. like this side upon this side, this base upon this base, this big side upon this side, they are all in the same ratio. Okay, so you can use the properties of similar triangles, and I will show that to you in some simple questions over here. Coming up, a man is 180 centimeters tall, his eyes are 10 centimeters below the top of his head. In order to see his entire height from toe to head, he uses a plane mirror at some 1 meter distance from him. The minimum length of the plane mirror required is how much? Okay, so let's draw an infinite mirror for now. Let's think of a Pandu over here. Let's think of a Pandu over here. His eyes are over here. Let's just show one eye for simplicity. Even if there are two eyes, it doesn't really matter. And the image of the Pandu will be formed exactly at the same distance behind the mirror, right over here. This Pandu has to see himself inside the mirror. Obviously, this distance, if it is x, this distance is also x. So if I show the extreme rays which should enter the Pandu's eyes, it will be something like this. It will be something like this. These are the extreme rays. So the mirror which I will need is only this much. This much part of the mirror is needed. The rest of the mirror is not at all needed. So this is the mirror which is not at all needed. So ignore it. So how much is this? Well, if this Pandu's height is h, even this Pandu's height will be h. Now I can see two similar triangles. Like I said, usually these questions involve some similar triangles. One triangle is over here and one triangle is big over there. Just visualize that. There is one big triangle of base h, like that. Like that. And inside that, there is one small triangle right over here. Right over here. So think, what is the height of that large triangle? What is the height of that large triangle? X plus x, which is basically 2x. 2x is the height of the large triangle. What is the height of the small triangle? What is the height of the small triangle? It is just x. The height of the small triangle is just x. So the triangle's ratio is basically, what is the ratio of the triangles? What is the ratio of the sides of the triangle? Ratio of the sides, it's basically 1:2 or 2:1. If this is 2, this is 1. So if this is h, what will this be? This will be h by 2. This base, this is 2, this is 1. So this is h, this will be h by 2. So it will be h by 2. What is the height of the person? It is basically 180 centimeters. So half of that should be 90. H by 2 will be basically 90 centimeters. That is the answer. Perfect. So does this matter? No. Does this matter? No. So how far you are and where your eyes are do not really matter. What matters is your original height. The half of it will be the minimum size of the mirror required to see yourself. Excellent. Awesome. Awesome. Moving on to the next question on your screen. This was asked in JEE 2019. A point source of light is placed at some distance L. You can see this is at some distance L, and you are walking along this line as shown. How much distance on this line will you be able to see the image of the light? This question is like this one. There is an object placed in the mirror. There is a field of view. So if you are here, you can see it. Beyond this point and beyond this point, below or up, you will not be able to see the image. So exactly same question has been asked, but now the values are given, distances are given. I think we can solve it easily. So see guys, first of all, let me show this to you very simply. The extreme rays will be this one, which will go like this. Oops. Like this, and then it will go like that probably, and then probably it will go like that. Okay, so these light rays will obviously go like this, and it will intersect this line between this point and this point somewhere over here. So this is basically your field of view. This is your field of view. Any other ray will pass through that field of view. Any other ray will pass through the field of view. But beyond that, you will see the rays will just go like that. You will not see a reflection coming over here. So that is your field of view. I don't know why I feel this is like a folded piece of paper. I feel that this triangle has been folded over. Maybe I just need to open it up. How many of you got that feeling right now? How many of you got that feeling right now? Maybe I can just open it up like this. I just open it up like this somewhere over here. So it's like opening up a piece of folded paper. It becomes like this. Perfect. So now what is this distance going to be? What is this particular distance going to be? If this was L, when you open it up, obviously that is also L. Again, you can see some similar triangles over here. One triangle is over here and the other big triangle over here. So I'll just repeat which are the two triangles. One triangle looks like this. One triangle basically is this one right over here, right over here. Okay. And the other triangle is that big triangle, guys. That big triangle. So just imagine that big triangle over here. Okay. So I'll just show it in one common shade over here. This particular big triangle right over here. Now these two triangles are similar. If you notice the height of the smaller triangle, how much was it? The height of the smaller triangle, it is basically L. The height of the big triangle is 2L plus L, which is 3L. The height of the very big triangle, this whole thing is L plus 2L, which is basically 3L. L and 2L over here is 3L. So the ratio of the sides, so hence the ratio of sides, how much is it? It is 1:3. This is 1, this is 3, this is 3, this is 1. That is what the ratio of the sides is. So if this particular distance is D, this is L, this is 3L, this is D, this will be how much? How much will this be? This will be basically 3 times of D. Hence, this distance of field of view is 3D, which is option number D. Perfect. Use similarity of triangles. Excellent, Lucky. Very good, Sadia. Awesome. Understood, my warriors? So, I have told you the trick for solving these questions. First of all, I told you that whenever you have to, where did it go? Find the field of view. Okay, just think about the extreme rays. Also, when you have to find the minimum size of the mirror, think of the mirror as an entry point into the virtual world. This trick, you can use it multiple times in different problems. Many times you might have to use similarity of triangles, parallel line properties, whatever geometrical aspects you need. Dream, I would suggest that you solve more problems like this. There are more problems in Tattva of this kind. There are more problems in Tattva of this kind. You can also watch my older classes. That's also fine. But I would say you need same model, multiple questions. So that's why you need a good book. Only then you will be able to achieve that confidence. You understood the concept, and this happens not just with you, with many students. Sir, I understood how you solved. I understood the solution also properly. I understood the concept, but I don't have that confidence. So for that, you need to play around with at least 2-3 questions of the same model. And that is what you will get in some good book like Tattva, or if you are enrolled in, Vedantu, any batch, you will see there is a good collection of problems which we give in the pedagogy. So we give a lot of free books, digital versions of many publishers like MTG and Disha and all of this. So you get these books for additional practice, and you have DPP generators also, where you suggest a topic and it automatically generates questions from that particular topic. So that is what we give in the pedagogy. It is a part of our Vedantu. So use these resources. That's the only way. You have to practice more questions. Now, the next question is about velocity of the image and the object. This is also a very interesting thing. Velocity of the image and the object, and there are two cases in this. One is when the object and the mirror are moving perpendicular, and second when they are moving parallel. So what do I mean by this? Oops. Imagine a scenario where this is the mirror. This mirror is like this, but the object which is there, is moving perpendicular to it. So this is VO, but this is in the perpendicular direction. Okay. So what will happen to the image, assuming even the mirror is moving with velocity Vm? Now let me tell you, in case of any plane mirror, however far the object is, exactly that far the image is from the mirror. So this distance from the mirror is the same. So if by chance the object moves with certain velocity with respect to the mirror, then even the image should move in the opposite direction with respect to the mirror with the same speed. So here what I will say is the velocity of the object, and here I would say velocity of the image. All of this with respect to the mirror. All of this with respect to the mirror. They are equal. They are equal, but you will see direction wise they are opposite. So hence I will put a minus sign. Hence I will put a minus sign. Do you agree with it? If object goes with 5 meters per second closer to the mirror, the image also has to come 5 meters per second with respect to that stationary mirror. All distances are measured from the mirror. Using this concept, I can find the velocity of the image. According to this, velocity of the object with respect to the mirror is equal to velocity of the image with respect to the mirror, but with a negative sign. By definition, V12 is V1 minus V2, so it will be Vi minus Vm. Again, by definition, V12 is V1 minus V2, so it will be Vo minus Vm. Take that Vm on the other side, or just you can do one thing, bring Vi on this side. Okay, so this is velocity of the mirror. Remember that. This is again velocity of the mirror. All right. So bring Vi onto this side. See what happens. You will get velocity of the image. Velocity of the image is equal to Vo goes on the other side as negative. Minus minus becomes plus Vm. This negative also becomes plus Vm. So it will become 2 times of velocity of the mirror minus velocity of the object. This is the formula that you get. This is the formula that you get. All these velocities are perpendicular to the mirror. They are perpendicular to the mirror. This is the formula. Velocity actually of the image is 2 times velocity of the mirror minus the velocity of the object. That is the logic. This is the formula. We'll apply this in many questions. Don't worry about it. One such question can be, what if there is a mirror which is moving with 3 meters per second, but the object is at rest? What do you think will happen to the image? What do you think will happen to the image? As per the formula, Vi is 2Vm minus Vo. Velocity of the mirror is 3. Object is at rest, so 0. So it will be 6 meters per second. And since the answer is positive, that means the image will move with double the velocity as that of the mirror. That's what it is. This is a sign sensitive equation because you can see there is a bar over there. It is like kinematic equations. V, U, A, S, all these are vectors, so you follow sign convention. Same thing over here. You have to make sure that they are sign sensitive, and accordingly you will get the correct answer, positive or negative. Very, very straightforward. What if the object or the mirror move parallel to each other? It's very simple, guys. I'll tell you what. Just imagine. I'll tell you 2 scenarios. It's very, very obvious. In the first case, let's say the mirror is moving. In the second case, let's say the mirror is at rest. Let's say the mirror is at rest. Here, our object is moving. Here, the object is moving. In this case, the object is at rest. Object is at rest. In this scenario, when the object is at rest, no matter what happens to the mirror, the image will also be at rest because it has to be in always front of it. Always has to be in front of it, no doubt. In this case, whether the mirror is moving, does not matter. If the object moves, the image always has to be in front of it. So the image also moves with the same speed. So Vi will be equal to Vo. So the image moves parallel to the object, parallel to the mirror. That's what happens in both these scenarios. Is that absolutely clear, guys? What happens in both these scenarios? This is case 2. This is your case 1. Okay. Very, very obvious. Let's use some questions for understanding the concept. Yep. What about this? There is a plane mirror which is approaching you at a speed of 10 centimeters per second. You can see that there is an image in it. At what speed will you see the image approach you? Plane mirror is approaching you at a speed of 10. So let's understand the question. And you are basically at rest. You are basically at rest. So this is that mirror. It is approaching at 10 speed. So what will the image do? What will the image? It will have some velocity which is 2Vm minus Vo. What is Vm? Vm is basically negative 10. Object is at rest. So it will be minus 20. So you will be approached by the image with a magnitude of 20 centimeters per second. Hence, the answer should be option number C. Hence, the answer should be option number C, because the question is about speed. Speed means the magnitude. So, minus 20's magnitude is basically 20. This is basically your speed. Remember, this was velocity. Velocity was negative 20. Okay. Right. Let's move on to another question coming up on your screen. Object is placed at a distance of 12. The virtual image is formed by the mirror. The mirror moves by 4 towards the object, the distance by which the position of the image will be shifted. Very simple, guys. Again, think about it. There is a mirror. There is an object. If the mirror is moved towards the object by 4, what will happen to the image? It will move double, right? It will move 8 centimeters. It will move 8 centimeters towards the mirror. This was asked in JEE Mains 2023. So if you're wondering, does these kind of questions come? They definitely do come. They definitely do come. JEE Advanced, Karthik. We will be doing Erodo level questions very later on, because I want you to first understand the overall understanding of the chapter. Then we'll have mixed problems. I want to do those things, but only after the problem, only after the syllabus is completed. Like in the next couple of months, we will have just revisions, just mixed problems, just one shots. We'll have formulas, we'll have tricks, we'll have advanced, mains, all kinds of questions once the syllabus is done. I'm just waiting for that day, and it all depends on you. You are support. If you keep watching, if you keep liking, if you keep commenting, if you keep sharing these videos with your friends, as the channel grows, the videos grow, then I can make that content. Understand that. Hi Lucky, Vanakam. All right, we can do even more problems before we go to this kind of question. Imagine there is a mirror like this. This is a proper level 3 kind of a question, where the mirror is moving like this with a speed of 2 I cap plus 3 j cap meters per second. And then you have an object which probably goes like this with a velocity of maybe minus 4 I cap plus 2 j cap meters per second. Question is, what will be the image velocity? Find image velocity. That is the question. Find image velocity. Whenever you get such questions in 2 dimension, always split it or solve it separately for perpendicular and parallel. So first let's do it for parallel, because that is the easier of the two. If you look at the parallel components, the object is going up with a speed of 2 meters per second, and the mirror which is there, the mirror is headed with a speed of 3 meters per second. With what speed the mirror goes does not really matter. If this is the object, the image always has to be in front of it. So 100% the image should have exactly 2 meters per second. It should only move with the object. What the mirror does not even matter. Correct? Now, let's look at the perpendicular directions. If you look at the perpendicular directions, this is what you are going to see. This is your mirror. The mirror is moving like this with a speed of 2 meters per second. The object is going this way with a speed of 4 meters per second, but this way. So I want to find what happens to the image. Use the formula Vi is equal to 2 times of Vm minus Vo. What is velocity of the mirror? It is right side, so positive. Object velocity is left side, so negative. Magnitude is 4. Y minus, sign convention has to be followed. So guys, this is 4 plus 4, which is basically 8 meters per second. Hence, this will be having a speed of 8 meters per second. So our final answer of the velocity of the image will be right side is 8, so 8 I cap. Upwards is 2, so 2 I cap. Sorry, 2 j cap. 2 j cap meters per second. That is the answer of the final velocity of the image. Understood how to solve these questions? Understood how to solve these questions of velocity of the mirror object moving with respect to each other in any random direction? You can split it into two small problems. One is parallel, one is perpendicular. For parallel, it is usually easy. For perpendicular, you just have to use this formula, which I just gave it to you right over here. Okay, which I gave it to you right over here. Okay, for parallel, it was simple. All right. Now, let's move to another concept in plane mirrors, where the plane mirrors are basically parallel to each other. When the mirrors are parallel to each other, then what happens? You might have experienced this in a barber shop. You see infinite set of images like this because there are multiple reflections happening. Okay, so what happens is, if you are the object, you will see your reflection, an image in the mirror. This image becomes the object for a mirror behind you. It forms another image behind you. That image becomes an object for the same mirror. It forms another image in front of you. That image becomes an object for the mirror behind you, and that process basically keeps on continuing. And that happens both sides. You will also see an image behind you. That will be the object for the mirror in front of you. And again, you will see an image behind that mirror, and that will be the object for the mirror behind you, and those multiple reflections keep on happening. So that is the reason why you see infinite images, but as you go far, you can see the image becomes dull, very dim, because the light gets scattered and the intensity of the light will reduce a lot. So the first few images are very bright, but after that, you will see it will become dull and hardly any contrast will be there. That is what you will see. So there will be infinite number of images, and you can see multiple reflections happening. This object is reflecting from this mirror, forming this image. That rays are again reflecting, forming an image here. And again, those rays are reflecting back and again forming an image here. And this also happens the other way also. So you will have multiple images in such cases. So you will always have infinite images, number one. Number two, the successive images are fainter. They are dull. Their intensity is less. Let's take a simple question to really understand this. So let's say we have two mirrors over here. This is mirror 1, this is mirror number 2, and let's say we have an object which is placed over here, and for simplicity's sake, let's take this distance, as 2 from here to here, and let's take this distance from here to here. Let's say we take it as, let's say 5, just taking some random values. Okay, 2 and 5. I want to see how the images are getting formed. I will show it to you step by step. So first step, guys, just consider mirror number 1. For mirror number 1, there will be an image which will be formed right over here. I will call it image I1, and this distance will be how much? It will be 2 meters or 2 centimeters. Exactly 2 ahead, so 2 behind. Is that right? Next step, what will happen? You will see that this image will be an object for this mirror, and this image is at a distance of, 2 plus 5, which is 9. So 9 meters ahead. So exactly 9 meters behind this. So exactly 9 meters behind this, somewhere over here, you will find the next image. Is that right, everyone? Got it? Yep. This 2 and this 7 will make it 9 meters in front of mirror 2. So 9 meters behind, you will get the next image. What's the next step? What's the next step? This image will be like an object for mirror 1. This distance is 7. This is 9. So totally, basically 16. So 16 meters or 16 units behind, you will find the image number 3. So this is basically 16 from here till here. Perfect. If this is 16 behind mirror 1, this image will be the object for mirror number 2. How far is it? 16 plus 7. Do you see that? This is 16. This is plus 2, which is 18, plus 5, which is 23. Oh, so 23 meters behind. 23 meters behind. That's really far. You are going to get the next image, which is I4. And that journey continues, and you will see infinite images. But there is a small catch. We only considered the first reflection from mirror 1. If you remember, it all started with mirror 1's reflection, then that image, then this image, then this image. But we also need to consider the second mirror as well, or else our answer is incomplete. So we should start with the second mirror. This object is 5 meters in front of mirror 2. So exactly 5 meters behind, you will probably see the first image by mirror number. This image will be like an object for mirror 1. This 5 plus this 5 is 10, plus 2 is 12. So 12 meters in front, so exactly 12 meters behind, maybe somewhere over here. This is your I2. This is basically I2, 12 meters behind. 12 meters behind. Is that right? Everybody with me on this? Now, next step. This image will be the object for mirror 2. So 12 plus 2, 14, 14 plus 5, 19. 19 meters in front of mirror 2. So 19 meters behind. So you will probably see exactly 19 meters behind. You will see, this will be 19. You will see image 3. This is 19 plus 2, 21, 21 plus 5, 26. So 26 meters in front of this. So 26 meters behind, you will find I4. This is what will continue. And this continues, guys. So you will get multiple images. All this has to be overlapped. So how the image formation happens? Again, multiple reflections happen, infinite types. So we took an example of some random object placed randomly in between two parallel mirrors. First reflection here. This acts like an object for this, forms an image here. This acts like an object for this, forms an image here. This acts like an object for mirror 2, forms an image there, and it continues. But we also need to consider this mirror as well. So this object will be reflected behind here, and that will be reflected behind here. That will be reflected there and here. And this journey continues. Everyone understood? Cheppandi, Solanga, Hedi, all languages I am telling, Telugu, Tamil, Kannada, Sangha, Bataiye, tell me, understood? Everyone? Okay, so this kind of questions may also come. Let's see if there is a question. Yeah, we have a question which was asked in JEE Mains 2023. Two plane mirrors A and B separated by 10. Object is 2 centimeters ahead of it. The distance of the second nearest image behind mirror number A is asked. All right. So let's start with our standard procedure. Two mirrors, you draw it. This is mirror A, this is mirror B. This is basically how much? 10. And in front of that, the object is placed 2 centimeters in front of it. So the first image will be formed right over here. This will be I1 and this will be basically 2. This 2 plus 10, the next image will be formed. So 12. Now is it audible? I think the battery would have died off. Now is it audible? Okay, perfect. But did you understand this question, my dear warriors, how this was done? So behind mirror A, the second image, that would be 18. Okay, this will continue infinitely. We just use the same procedure how I did this particular problem. No difference at all. Perfect. Let's move now to inclined mirrors. Let's now move to inclined mirrors. Okay. Okay. So this also, I'm pretty sure you would have experienced this in many places. Especially there is a door, there is a mirror behind. If the door turns and there is a mirror on the other wall also, these two mirrors are no longer parallel, they are inclined. Then you will see multiple images, but they are not infinite, rather they are finite. So the change over here, when the mirrors are at an angle, it is no longer infinite, but rather finite number of images. Finite number of images. Not just that, they are not behind each other. You will see that these images are in a circle. Yes, so these images are in a circle. Very, very important. So if you see the top view, if this is the, if these are the two mirrors inclined over here, and let's say one object was placed here, just imagine a circle of sorts, let's say like this. Imagine a circle of sorts, something like this. Like this, you will see all the images will be on this circle. Maybe one image here, 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 maybe one here, like this. So the images I1 to IN are in a circle. This is what happens. Instead of when they are parallel, when they are in parallel, you will see the circle becomes so big, it becomes a straight line. Just visualize this. Had these mirrors almost been parallel, the circle will be so big that it will be in a straight line. That's why you get infinite images. So as and when you slowly increase the angle, the circle becomes smaller and smaller. The circle becomes smaller and smaller. That is exactly why you get finite number of images. That is a very interesting thing. And there is a formula also for that, to find how many images are there. Otherwise, you have to break your head in the examination as to how many images are formed. What you do is divide 360 degrees with theta. Divide 360 degrees with theta and see what is the answer. Is it even or is it odd? Based on that, see whether it is symmetric or asymmetric. Symmetric means it's exactly placed on the angle bisector. The object is placed exactly in between the two mirrors. Asymmetric means maybe it is not on the angle bisector, it is somewhere here, or it is somewhere here, or it is somewhere here, not on this symmetry line. In such case, use the asymmetric formula. All the times it is 360 by theta minus 1. It is 360 by theta minus 1, except for the case when it is odd asymmetric. Only remember this special case. For odd and that too asymmetric, it is just 360 by theta. For everything other angle, whether odd, even, asymmetric, symmetric, it is 360 by theta minus 1. Let's take examples and understand it. Imagine if I tell you the angle between the mirrors is 90 degrees. How many images are formed? First things first, what I will do? I will divide 360 divided by theta, which is 360 divided by 90, which is 4. Now check this out. 4 is an even number. 4 is basically an even number. Now imagine the object which is there is placed somewhere over here. It could be anywhere if this is the object. Doesn't matter whether it is symmetrically placed or asymmetrically placed. The answer is 360 by theta minus 1. So the number of images which will be formed will be 4 minus 1, basically 3. So the other images, one will be here, one will be here, one will be here. So these three images are formed around it. Similarly, another example, let's say the mirrors are like this at an angle of 120 degrees. Okay. Then if you divide 360 by 120, what you get is 3. Very interesting. 3 is an odd number, so now it matters whether it is symmetric or asymmetric. So in a case where it is symmetrically placed, meaning 60 degrees, then the number of images for symmetry is 360 by theta minus 1. So it will be 3 minus 1, which is basically 2. So you will get probably one image here and one image here in a circular form. But if it is asymmetric, maybe the object is over here, then the number of images will be 3 only. That is 360 by theta. That will be 360 by theta. So this was symmetric, the blue one. The pink one is asymmetric. Understood how to use this formula, my dear warriors? Very, very straightforward. Very nice. So you give any angle, you will be able to figure this out. After this, there is no difficulty in that. But JEE is capable of asking very interesting questions, and that's what they did. Look at this. There is a person in a room whose ceiling and two adjacent walls are mirrors. How many images are formed? This was one of the most interesting questions. How to find whether symmetric or asymmetric? It will be given in the question. Like they might tell you, there are two mirrors and there is an object which is placed on the central line. And let's say this angle is 60 degrees. And let's say this is the object. And let's say this is the angle bisector. Then what you will do? Again, you will divide 360 by 60. In this case, it is 6. 6 is basically even number. Now, it doesn't matter whether it is symmetric or asymmetric. The answer is 360 by theta minus 1. So there will be 5 images. That means there will be one image here, one image here, one image here, one image here, and one more image here. So there will be 5 images around it. That's what it means. Is that clear? How to do this? Perfect. Okay. So how about this question? Because there are mirrors on the side walls, including the ceiling. I'll tell you how to look at this problem. Imagine a scenario like this. Hmm. Imagine this is the mirror, set of mirrors, and there is a Pandu who is standing here. There is a Pandu who is standing here. Now, no matter which orientation you look, you will always see perpendicular mirrors. If you look at it from the top view, you will see two mirrors like this, and you will see Pandu's head over here. So basically, this angle is 90 degree. Hence, the number of images in this case, think about it, will be 360 by theta, which is 90, which is basically 4. 4 is an even number, so you have to subtract 1 from it. So 3 images. So you'll see one image here, one image here, and one image here, like this in the same plane. Now, if you look at him from the front, again, these two mirrors are perpendicular. So you will see one image here, one image here, one image here, 3 images. If you look at him from the top, then one image behind, one image here, and one image here. So no matter how you see, you will always see extra 3 images in that same plane. So my dear students, you know what? Actually, you should construct a hypothetical cube. You should construct a hypothetical cube now. Exactly. So imagine a cube like this. This is Pandu. You will see Pandu's images in the following way. Just imagine a hypothetical cube like this. Just see if you're able to visualize the first part of the cube, the floor of the cube. Each cube is where either an object is or an image is. I hope you can see there are 4 cubes now. This is the object, one image here in this cube, one image here in this cube, one image here in this cube. Similarly, imagine 4 such more cubes on the top. Imagine 4 such more cubes on the top, somewhere over here. Just visualize this. Are you able to visualize? There are 4 things here, 4 things on the top. Except for this object, there are totally 7 images in those 7 cubes. Are you able to visualize 7 different cubes, my dear warriors? Are you able to visualize 7 different cubes? It's basically a big cube. It's basically a big cube of two, I would say, 2 smaller cubes on each side. 2 smaller cubes on each side, something like this. Somewhat like this. That orange one is this part. It's only this particular cube. Orange one is only that particular part. That's it. So there are 8 cubes in it, out of which there is one object here. The remaining, all of them have images. The remaining, all of the cubes have basically 7 remaining cubes have 7 images. They have 7 images. Exactly. So the answer is D, which is 7. What an interesting question. What an interesting question. Hello, Magati. How many of you loved this question? How many of you loved this question? Yep. Are you able to visualize what just happened? So these two walls and the upper ceiling were all mirrors. If you just consider the walls which are there, if you look at him from the top, you will see 3 images here. If you look at these two, you will see 3 images like this. If you just see these two, you will see 3 images like this. So in any direction you go, 3 images like this, 3 images like this, okay, 3 images like this. So, you know, they are getting reflected. So you can imagine a big cube over here, and that big cube has smaller 8 such cubes, out of which one cube is occupied by the object itself. So hence you will say 7 cubes have those 7 images. Very good. I don't know whether that dotted lines are seen very clearly or not. Yeah. So, Dharnishwaran, you have to just think as if this room is there. One image is in the neighboring room. One image is in the another neighboring room behind you. Another diagonal room there. Okay. Now, because the roof is made of a mirror, whatever is there in this floor will be replicated on the top. I am there. One image is there. One image is there. One more image is there. I am here. One image is there. Another image is diagonal. Another image is behind me. Because of the top mirror, everything gets replicated. So 1, 2, 3, 4 gets replicated on the top plus these 3 images, totally 7 images. Understood now? Think of it like this. Okay. Very good. Awesome. Now, moving now to spherical mirrors. Ready for spherical mirrors, my dear warriors? Ready for spherical mirrors? Great. See, let me tell you, when we studied the laws of reflection, we drew a normal, we had an incident ray, reflected ray, and all of that. We said this angle is equal to this angle and all of that. It's not just valid for plane mirrors, but also for any kind of curved mirrors. On a curved mirror, you can have many such normals, and you can have many rays which are falling onto it. At every single place, the law of reflection holds true. So these laws of reflection not only hold true for plane mirrors, but obviously a curved mirror is made of many small flat mirrors, like one flat mirror here, one flat mirror here, one flat mirror here. So the laws are applicable even for curved mirrors. Now you take a spoon and see yourself. That's basically a curved mirror. From one side, it is caved in, that's called as concave side. From the other side, where it bulges out, where it comes out, that is the convex side. You see the rear view mirror or the side view mirror of your bike or car, you will see that is also curved mirror. In a parking lot, you might have seen a reflecting mirror for seeing other people coming from different sides to prevent accidents. That's also a curved mirror. In your TV antennas, what is there is again a curved mirror. You are trying to accumulate the solar energy and concentrate it at a point to burn some food or cook some food. That is again a curved mirror. So curved mirrors have a variety of applications. You have 100% seen it somewhere or the other. Depending on which side is reflecting, it will be called concave or convex. Vex is bulging. Cave is basically caved in. You are taking a cave. Cave is like a hole inside a mountain. So this is caved in, this is concave. So the rays will get reflected here, whereas for convex, the rays will get reflected here. This curved mirror is actually extendable to a complete sphere. That's why the topic is also called as spherical mirrors. Just because it is an arc does not mean it is not a circle. It's just that the other circle, other part of it is missing. So an arc is a part of the circle. So it is also called as the spherical mirror. The center of the sphere will be called as the center of curvature. The radius of that imaginary sphere is called the radius of curvature. It's called as the radius of curvature. So this is basically your radius of curvature. This is center of curvature. If you break the mirror into two equal parts, what you get is basically a point on the mirror which is called as the pole. This point is basically called as the pole of the mirror, which breaks it into equal halves. If you join the line from the pole to the center of curvature, that line is basically called as your principal axis. What is it called? It is called as the principal axis. As simple as that. Okay, these are the basic terms which you should definitely be aware of. Now, whatever formulas, etc., you learn henceforth, whether it is convex mirror or whether it is concave mirror, all these formulas, you will notice one thing. all these formulas, you will notice one thing. There is a assumption, and the assumption is our rays are very close to the principal axis. Our rays are making small angles and they are very close to the principal axis, basically paraxial rays. Paraxial rays. They basically make small angles and are close to the principal axis. They are close to the principal axis. Example of a non-paraxial ray will be somewhere over here. Imagine this ray. 100% it is not a paraxial ray. 100%. Even this ray over here, making a large angle, hitting somewhere and going like this. This is not a paraxial ray. The yellow ones are paraxial rays. Okay, it makes our assumptions and calculations easy. Now, in case of a convex versus a concave, this is your convex. If I show the principal axis, this is our pole. There will be also center of curvature somewhere over here. There will be center of curvature somewhere over here. If you have a parallel beam of light, if you have parallel beam of light, then that beam for a convex will diverge. Will basically what? It will diverge, and it will diverge from a point. Whereas for concave mirrors, a parallel beam of light will end up converging at a point. Will end up converging at a point. This point is the focal point. It appears to diverge here from this point. So this is basically your focal point. So focal point is the point of convergence or divergence. So F is your point of convergence or divergence. And this distance from the pole to the focal length is denoted by small f. All distances are always measured from the pole. That f, small f, is called as the focal length. What is it called? It is called as the focal length, always measured from pole. Always measured from where? The pole, not from the center. Is that absolutely clear? Everybody with me till this point? Now this focal length has a relationship with the radius of curvature. If you remember radius of curvature, just some time back I had told you this is radius of curvature. Yes, that's right. This particular thing was your radius of curvature, and the focal point, which I just mentioned right now, which is, let's say, either here or here. For the convex, it is here. For the concave, it is in front of it. This particular length was your F, or this particular length was your F. You will see that 2 times of the focal length is basically the radius of curvature. A very important formula which you should remember. Radius of curvature, you can see, is double of the focal length, or I can also say F, the focal point, is midpoint, is the midpoint of who and who? Think about it. Of the center of curvature, basically over here, and the pole, and the pole, and the pole. It is exactly midway between the pole and the center of curvature. Another way of looking at it. R is 2F, or focal point is midway between the two. All right, all these are important things. Now, for drawing the ray diagram, there are certain rules which you must know, like as follows. If I want to find where the image is formed, I need at least two rays to form the image. I need at least two rays to form the image. So if a ray is parallel, to the principal axis, after reflection, it will pass or appear to pass through the focus. That is the first rule. It will actually pass through the focus or appear to pass through the focus after reflection. That is your first rule. You will see that there is exactly opposite rule of this as well. That is, if a ray passes through the focus or it appears to pass through the focus, after reflection, it will become parallel to the principal axis. After reflection, it will become parallel to the principal axis. If it appears to pass or actually passes through the focus, then it becomes parallel to the principal axis. This is nothing but reversibility principle of light. Instead of incident, I make the reflected light as incident, then the incident will become the reflected. So this is incident, this is reflected. If I make this incident, this will become reflected. So that is the reversibility principle of light. This is another way of approaching where the image is by drawing the rays. You need at least two rays, remember that. That's why we are showing this. Another thing which you can do is, if you know where the center of curvature is, this is the center of curvature, this is the center of curvature, you show a ray passing through the center of curvature or reaching the center of curvature, appearing to pass through the center of curvature, you will see it will rebound back the same way because it will hit the surface normally. If it enters like this, it will also come via the same path because this is going to be perpendicular. This is going to be perpendicular. That's the reason why it will retrace the same path. So that is true if the ray passes through C or appears through pass through C. And the last rule is, if the ray is incident on the pole, it will reflect on the other side symmetrically. It will reflect on the other side symmetrically. Very, very easy rule. This angle will be this angle. This angle will be this angle. Using these rules, you can find where the image is in any given condition. For example, say this is my concave mirror. This is my concave mirror, and I want to know where the image is formed in this particular scenario. I tell you, listen, the center of curvature, okay, is, let's say, over here somewhere. This is center of curvature, so focal point will be exactly midway in between. And let's say it is given to me, my object is placed over here. Let's say the object is placed here. I want to know where the image is formed. What I will do, I have multiple rays which I can draw, any of these four rays which I can draw. This is the first option which I had. This is the first option which I had. This is the second option which I have. This is the third option which I have. And this is the fourth option which I have. I can use any of these four rays to find the image. But remember, I just need two rays to actually find the image. So what I will do, I'll just show, let's say, a parallel ray right now. Let's say I just show a parallel ray for now. What will happen? It will end up passing through the focal point. It will end up passing through the focal point. Okay, this is one. Another ray, maybe I can just show passing through the center of curvature. It will just retrace back the same path. Okay, so this ray will just go over here, and this ray will just rebound back as it is. Where are they meeting? They are meeting over here. So exactly, there is an image which is formed here. So this is where the image is formed. You can see it is inverted. First of all, the rays are actually meeting. So hence it is real. You can see the image is also smaller size, so I can call it diminished. It is diminished. So this is how you locate the image using ray diagram or ray tracing. So this is how you obtain the diagram using ray tracing. So for ray tracing, remember, minimum, you will need minimum 2 rays. That's all. 2 rays are enough to locate where the image is formed. Till this point, if it is clear, then let me show you the basic table over here. Sir, I wanted to join Vedantu dropper batch for JEE, already having Tattva books. What can I do? That doesn't matter if you have Tattva books or not. I mean, the JEE dropper batch is much more than just Tattva. It is classes, it's doubts, it's more books, it's assignments, test series, mock tests, mentorship, guidance, proctoring, 2 teachers, student academic mentorship. All those things are there. So it's a small cost. The Tattva book is a small cost of the the entire thing that you are getting. So that should not be a deciding factor when you are thinking about joining the dropper batch. So at different locations, if you place the object where the image is formed, there is a beautiful table. But rather than just showing you the table, I thought, why not show you the animation for this? So here we go. Look at this. This is a concave mirror. I hope you are able to see it. This is a concave mirror. Maybe I change it like this. I hope you are able to see. This is the focus at -4. So the center of curvature is at -8. Kind of makes sense because focus should be always midpoint. If I put the focus over here, you can see at 2, the center of curvature comes at 4. Correct? You can see that. If I put it as 3, it will come at -6. So this is basically your concave mirror. You can see the object is here. I can move the object and the image will also end up moving. Now notice over here, okay, notice over here, this is the object. When the object is really far, if I go far, but I can't go really far now, the image will go to the focus. Yes, makes sense. If I'm very far, the image will be formed close to the focus. As I come close, the image moves away from the focus. It becomes larger, larger, larger. It is inverted. It is real. It is diminished. But the moment I come to the center of curvature, it is exactly the same size and inverted. And then when I take the object onto the other side, then you will see the image becomes enlarged. And then finally, when the object reaches the focus, you can see the image is at infinity, exact reverse. And after the focus, see what is happening. These 2 rays end up converging on the other side. That means you will get a virtual image because this is behind the mirror. This phenomena is used by a dentist. What they do, they use a concave mirror and place it close to the tooth being the object. And they hold the mirror behind the tooth. The tooth is here behind the tooth. They hold the mirror. So inside the mirror, they see an enlarged image. Inside the mirror, they will see an enlarged virtual image, which is erect. This is the exact application of concave mirrors by a dentist. Okay, you can see the image is enlarged and erect. If you go on to the other side, now this side, if it is exposed to the light and this is silvered, this will become like a convex mirror. And you can see an interesting thing for a convex mirror. The image is always small, no matter where you are. Image is always small. It is erect and it is always behind the mirror. Now this is behind the mirror for this surface. So it is always virtual, it is diminished and it is erect. This is what you will see. It's between the pole and the focus most of the times, you can see. Yep, everybody understood how this works? Very, very interesting. Very, very interesting. Great. So this is how this particular table is made. Okay, and you can also make this table by drawing the ray tracing diagram. But every time we can't use the ray tracing, you have to use formulas. So we'll learn the formulas, but before that, we need to know the sign convention. So what is a sign convention, guys? Let's have a look at it. What is the sign convention going to look like? Observe this carefully. Whether it is a mirror, lens, anything, doesn't matter. Whichever direction the incident light is, whichever direction the incident light is going, that side of the pole becomes that side, arrow mark is towards that side becomes positive. So this becomes the positive coordinates. Automatically, these become the negative coordinates. It's only dependent on the direction of the incident light. Same way, imagine it was something like this over here, or let's say something like this over here, whereas the light which was incident was coming in this direction. This was the direction of the incident light. The pole is always the origin. The pole is always the origin, obviously, because the light is coming towards this side. Check the arrow mark. So this will be positive and this will be negative. That's all. This will be positive and this will be negative. That's all. Is that simple? Understood? Clear? Everybody with me? Everybody with me? Understood? Okay. So, say for example, my dear warriors, I tell you, hey, listen, there is a concave mirror. Listen, there is an object over here. Can you tell me the object distance? U is the symbol for object distance. V is the symbol for image distance. Focal length and radius of curvature, assume that the image is formed, let's say over here. This is where the image is formed. So what you will do is, first of all, see how the light rays are coming from the object. From the object, the light rays will come like this. The pole is exactly here. So this is basically your positive side. Naturally, this side will be negative. So the object distance always measured from the pole is negative. You can also notice that the center of curvature, focal point, everything is on the negative side. So hence, even the focal length and the center of curvature, which decides the radius, is also going to be negative. So bear that in mind. Bear that in mind, that center of curvature decides the radius. So for radius, do not look at, sir, my R was like this, sir, so that side is positive. No, sir. No. Check where the center is. Center is on the negative side, so radius is negative. For focal length, don't mark some arrow mark. No, check the focal point. It is on the negative side, so focal length is negative. So the only thing which is positive is the image distance. Similarly, if I had a convex lens, let's say like this, and let's say there was an object over here, and let's say the image is formed over here. Okay, just taking some random example, we know that the center of curvature and the focal point, everything will be on this side. From the object, the rays will emerge like this. So they are going to that side. So hence, this side will be positive, whereas this side will be negative. So observe now what will happen to object distance, image distance, focal length, and radius of curvature. Which and all are negative? I can see one negative, which is object distance. Object distance U is negative. Image distance is always measured by V. That is on the positive side. Focal point and center both are on that side. So these both are going to be positive. Is that clear, everybody? Yep. Awesome. User phone, both have their own differences. So Pro batch is a more intensive batch. It has more features like proctoring. You get hard copy of Tattva. You have doubt solving beyond the classes. You have mentorship. You have student academic mentor. Then you also get more classes. It is more intense program. Prime is the affordable version. So you have your YouTube teachers, okay, and you do not get hard copy, you have the soft copy, and you do not get doubt solving after the class and all of that. Okay, so that is the major difference between both of them. Got it. Awesome. Now, once you understand what is the signs for object, image, focal, radius, the next thing which comes is where is the image? Where is the, object if image is given? There is a direct formula. How much is the magnification? All of this, there is a direct formula. So let's have a look for the spherical mirror formula, then the magnification formula, velocity, and then probably we'll go to problems. Okay. So let's start with it. The mirror formula. If you are given a mirror, doesn't matter which type of mirror, object is here, image is here, doesn't matter where object and images. This is, let's say, object distance, this is, let's say, image distance, you know the focal point, you know the center of curvature, etc. Then the mirror formula is as follows: 1 by object distance plus 1 by image distance is 1 by f, where your focal length is r by 2. This is, as simply put, the mirror formula. Everything, put it with signs. They are sign sensitive equations like kinematic equations. V is u plus at, s is ut plus half at square. Same way. Yeah. Dharaneshwaran, the plan is to conduct for prisms also. I'm not sure how much time we'll get, but even if it doesn't happen, it will be conducted in part 2. Don't worry about it. Okay. Next, magnification formula. See, imagine the object is having a height of HO and the image is having a height of HI. This is your image. Then magnification by definition. Actually, there are two kinds of magnification. We'll come to it. Magnification by definition, which is also called as your lateral magnification. I'm putting it like this because it is perpendicular to the principal axis. Whenever it is perpendicular to the principal axis, it is called lateral magnification. That lateral magnification, my dear warriors, is how much is the height of the image upon how much is the height of the object. Height of the image by height of the object. Now, depending on whether it is positive or negative and stuff like that, you know whether it is inverted or not inverted. For example, if it is positive, I know that it is erect. If it is by chance negative, I know it is inverted. And by chance, if it is 0, then it is neither erect nor inverted. Maybe the image is not formed only. So that's why we don't consider that 0 case. All right, that means no image is formed. So you ignore that. Also keep in mind one more thing. By chance, if the magnitude of the magnification is more than 1, that simply means that the image is magnified, or basically it is enlarged. Then for diminished and for no change, what will be the magnitude? Well, if the magnitude is less than 1, it is diminished, and if the magnitude is equal to 1, then there is no change. For example, if I tell you the magnification is +3, that means it is enlarged plus it is erect. If I similarly tell you the magnification is -0.6, it is inverted because it is negative. Because it is lesser than 1, it is smaller. The image is smaller. It is diminished. If I tell you the magnification is -1, it is inverted and it is of the same size. If I tell you the magnification is just 1, then it is just erect of the same size. So that's how, looking at the magnification, one can easily guess whether it is diminished, erect, magnified, etc. That's all. And for a mirror, this HI by HO, this HI by HO comes out as follows. This magnification, which is also called lateral magnification, which is height of image by height of object, comes out as minus V by U. This is the formula. So keep this in mind. The magnification is image distance by object distance with a negative sign. If you miss the negative sign, you might get a wrong answer. So be careful. Yeah. Yes, I mentioned it. How many questions can come from this chapter at the beginning of the lecture only? Okay, so you can watch the start of the class. All right. Now there is another kind of magnification which can happen. Another kind of magnification which can happen in case of a mirror. So if this is the principal axis, this is our object, along the principal axis, the length can change. If this is the object, not just perpendicular, but along the principal axis, the length can change. So this is the length of the object. This is your image. This is the length of the image along the principal axis. What you get is the longitudinal magnification. This is along the principal axis, so longitudinal. This is length of the image upon length of the object. This has the formula minus V by U, but you square it. That's the only difference. This was just V by U negative sign. This is minus V by U, but you square that V by U. That's all. Or V square by U square with a negative sign. That's the only difference. But keep in mind, this is only applicable for small lengths only. For small lengths only. For large lengths, this is not applicable. What to do if there are large lengths? We will solve a problem like that also. So shortly. So this is longitudinal magnification, which is along the principal axis. Just to give you an example, imagine there was a cylinder which was of height h and radius r, which was placed, okay, in front of some mirror over here, maybe concave, convex, and because of which there was an image which is formed. Let's say the object distance was minus 2 centimeters. The image distance was plus 6 centimeters. Can you redraw the new cylinder? Can you redraw the new cylinder based on this given information? Well, image distance is negative, kind of makes sense because it is on the negative side. Object distance is negative, kind of makes sense because the object is on the negative side. Image distance is positive, so the image will be on the other side. So this was your object. Your image will be somewhere over here. But I don't know how big or small it's going to be. Now, if I visualize the principal axis, it will be something like this, right? The height and the radius of the cylinder will change. You have placed a small cylinder coaxially along the principal axis of a concave mirror. How will it change? That's the interesting question. So I will find two kinds of magnification here. The first magnification which I will find is the perpendicular magnification, which is just minus V by U, which is minus of V is 6, U is minus 2. So it is going to be 3. 3 is positive, minus minus has cancelled. So it is erect and it is enlarged. You have enlarged it. Okay. What about the other magnification? What about the longitudinal magnification, which is minus V by U whole square? So it will be minus V is 6, U is minus 2. 6 by 2 is basically 3, but you have to square it, which will make it minus 9. That means along the principal axis, it has been inverted, but 9 is more than 1, so it is again enlarged. it is enlarged. So imagine this cylinder had some shaded base and shaded side and non-shaded side. By this information, laterally perpendicular, it is enlarged 3 times, so the radius will become 3 times. The radius will become 3 times. Along the principal axis, it will become 9 times. So the height will become 9 times of h. 9 times of h, guys. Very, very interesting. The image will be, it will be basically 9 times of h. The radius will become 3 times. The radius will become 3 times of r. But remember, this is negative. That means along the principal axis, things will be inverted. Not like that. Along the principal axis, it's negative. So it is inverted along the principal axis. So you will probably see it this way. This will be shaded. This will be the shaded part. And this will be 3r. Understood? So this is how your image will look like. This is how your image will look like. No, negative means inverted or enlarged. See what I have mentioned? Negative means inverted or erect. Sorry. Positive means, yeah, negative positive means erect or whether it is inverted. The magnitude tells you whether it has been elongated or whether it has been diminished. Just like here, negative 0.6, negative means inverted, positive means it is erect, 3 means enlarged, 0.6 less than 1 diminished. So that is the reason why, because it is negative, it is inverted, because it is 9, it is enlarged. Is that clear? Yes, Sai. Everyone? Clear? Oh, understood? Oh, pakka, done, dusted. Can we move ahead? Did you understand the difference between lateral and longitudinal magnifications? Absolutely, everyone. Very good. Last thing is velocity. Remember, there was a formula for velocity of image for a plane mirror. There is also a formula for curved mirrors as well. So if you have an object which is moving with a velocity of VO, and then you have an image which is moving with a velocity of VI, then the velocity of the image upon velocity of the object is simply this formula. M longitudinal is simply M longitudinal formula, which is along the principal axis, meaning minus of V square by U square. That's it. That is the formula for velocity of the image upon velocity of object. It is very, very straightforward. If you remember longitudinal magnification, you also get velocity formula. Just like, for example, in this case, just for the sake of giving a problem, imagine this was moving with a speed of 3 meters per second, or let's say it was moving with a speed of 2 meters per second. What will be the velocity of the image? Well, according to the formula, velocity of image by velocity of object is just m longitudinal. This m longitudinal, we just got it as -9. Velocity of the image, I do not know. Object is moving right side, so +2. Had it moved towards this side, I will substitute -2. Solving this, I'll get this as -18 meters per second, which means this image, this big cylinder is moving this way with a speed of 18 meters per second towards the left side. That's what it means. As simple as that. I hope this is very, very clear. Nagaraju, you will get banned, bacha, for talking such random shit like that over here. Why do you want to get banned? It's very simple. Our policy in Vedantu on this particular channel, any spam we see if it is moderate, we just time out, we give a warning. If it is something which is derogatory to the teacher or anything, we don't tolerate, we straight away block. It's very simple, so don't waste your time. unnecessarily your account will get blocked. You will not be able to comment, chat, anything. Okay, it's a very simple policy. Same rule applies even inside Vedantu. We don't, there is no second chance, just block straight away. Okay, cool. All right. So let's start solving some questions. Coming up on your screen, a convex mirror has its radius of curvature 20. Find the position of the image of an object placed at a distance of 12 from the mirror. Okay, come on, my dear warriors. What will you do in this particular question? A convex mirror. Let's draw the diagram. Without that, we should not go ahead. So this is a convex mirror. This is your principal axis. Radius of curvature is 20. So center will be here. Focal point will be here. And object is placed at a distance of 12 from the mirror. So this is where your object is at a distance of 12 centimeters. From the object, the rays of light will go like this. That means this should be the positive side, and this over here should be the negative side. Now, clearly it is mentioned the curvature is how much? 20 centimeters. So the focal length will be 10 centimeters. Will be 10 centimeters. So let's use the mirror formula, which is 1 by V plus 1 by U is 1 by F. Image distance, don't know. Object distance is negative 12. Focal length is basically 10 on the positive side, because you can see F is on the positive side. Object distance was negative. So 1 by V is equal to 1 by 10 plus 1 by 12. So the LCM, we can just take it, let's say 120, for example. So this will go 12 times, this will go basically 10 times. So this will just become 22 by 120, which is 11 by, if you divide by 2, this will just become 60. So that was 1 by V, mind it. So therefore, V will be the reciprocal of it, which is 60 by 11. Everything was in centimeters. Yes, 60 by 11 centimeters. Let's find out. Yes, that's the answer. 60 by 11 centimeters. Because since this answer is positive, that means the image is formed on that side. That means the image is basically virtual. The image is basically virtual. If it is on this side, it is behind the mirror, so it is virtual. Had the image formed here, that means the rays are meeting at this point. So then the image would have been real. Then the image would have been real. In this case, it is a virtual image. Exactly. Very nice. Moving on to the next question. First, we are getting a hang of the situation, getting a hang of the formulas, then slowly moving ahead. Now we have a concave mirror, some focal length, everything is given. So always start with a diagram. So this is your concave mirror. This is your principal axis, center of curvature, focal length. Focal length is already mentioned to be 10. And then what else is given? The object is at a distance of 8 from the pole. Object is placed over here at a distance of just 8. The rays will go this way towards that side. So hence naturally this side will be positive, whereas this side will be negative side. So let's use our mirror formula to find the position and the nature of the image. 1 by V plus 1 by U is 1 by F. 1 by V plus U. U is basically minus 8. Object is negative 8. Focal length is also negative. It is minus 10. So therefore, 1 by V is equal to 1 by 8 minus 1 by 10. So you can take the LCM. That's 80. 8 goes 10 times. 10 goes 8 times, which is basically 2 by 80, which is basically 1 by 40, which is 40 centimeters. Because this is positive, it means it is virtual. It is virtual. It is on this side, 40 centimeters. So the image is here. The image is here on the virtual, behind the mirror. But you also have to find the nature of the image. So let's proceed even further. What is the magnification which I will get? The magnification, which is minus V by U, is minus. V is basically 40. U is 8. with negative, minus minus cancels. So the magnification is positive 5. That means it is erect, and 5 means it is enlarged. It is enlarged, it is erect, it is virtual at a distance of 40 centimeters from the pole. Perfect. This is how you will give the final answer. Yes, 40 centimeters virtual, and you will also see it is enlarged. If there are options like image is virtual, image is real, image is diminished, image is enlarged, image is erect, image is inverted, multiple choice, maybe in advanced, yeah, you can give it accordingly or match the following. Next, this is from the Tattva module. I have just taken it from this particular book, the Tattva module. The link is there in the description in case you want to buy this book. Okay, all the chapters are there for all the 3 subjects for less than 5,000 rupees. You will get the hard copy couriered to your doorstep. It has 4 level problems, additionally solved examples, additionally QR code is there to scan it. Yes, you will see that there is QR code. What is the purpose of this QR code is basically you will be able to see the video solutions as well as video lectures on that particular topic. That is the advantage. It's a very interactive book. That's how you use it. Calculate the distance of an object of height h from a concave mirror of focal length 10 so as to obtain a real image of magnification 2. What does this mean? I want basically a real image of magnification 2. From a concave mirror. Basically, this is your positive, which is virtual side. This is negative, which is your real side. The image is real. Image is real. From this, what do you get? V must be basically negative. Magnification is 2. That means M has a value of 2. Now, whether it is plus 2 or minus 2, how do I know? I know the object will be placed in front of it. So object is somewhere here only. So object is also negative. So when I find V by U, what will it be? It will be negative by negative, which will make it positive. So the magnification, which is negative V by U, because V by U is positive, it will be negative. Hence, the magnification is minus 2. Did you get it? Why the magnification is minus 2, my dear warriors? Why the magnification is minus 2? Because V is negative, U is negative. So 3 negatives will make a negative. The magnitude is given to be just 2. So this means it is just inverted. It just means it is inverted and it is enlarged. It is inverted and it is enlarged. Now the question is, find where will you place that object for this particular focal length. All right, let's find it out. It is not that difficult. What we can do is use the mirror formula and then go about it. Okay, we just have to use the mirror formula and then go about it. Yes, and in the mirror formula, the problem is I don't know U also, I don't know V also, but one thing I know, magnification is minus 2. So I can use it over here. I can use it over here. So the magnification is minus 2, which is minus V by U, minus minus cancels. So V will be 2 times of U. This is one very, very interesting result which I can use. V is basically 2 times of U. So let's use this. 1 by V plus 1 by U is 1 by F. I want U, so I'll substitute V as 2 times of U, 2 times of U. So plus 1 by U is 1 by F. F is 10 centimeters. Focal length is here. Remember that. Do not forget it is on the negative side. So it will be minus 10. So half plus 1 is 3 by 2. So it will become 3 by 2U is equal to 1 by 10. 2 cancels with 10 and you will get it as 3 by U is equal to 1 by 5. So cross multiplying, U goes this side, it will become 3 multiplied by 5. So it will become basically 15 centimeters. U will become magnitude wise 15 centimeters. Yes, correct. Very good. Awesome. Very good, Dharneshwaran. Awesomeness. Proud of all of you guys. Understood, guys? So this is how mainly the problems are. Okay, you have to use mirror formulas, and solve the questions. Okay, so let's go to the next question. By the way, this was from Tatva. Remember, the link is there in the description if you want to buy this book. Let's solve now level 2 question. Level 2 question. Okay, in Tattva also you are going to get all these kind of levels. In fact, here we are doing 3 levels. In Tattva you will get 4 levels of questions. 4. Yep. There is some rod of certain length on the principal axis, focal length 10, such that the end closer to the pole is 20 away from it. Find the length of the image. Okay, let's draw it. Concave mirror. Let's draw a concave mirror. This is okay. Let's do one thing. This is positive side. This is negative side. This is your pole, which is also the origin. Okay. And then what is happening? You are placing a rod of length 10, of focal length 10, in such a way that the end closer to the pole is 20 centimeters away. 20 centimeters away. And the rod of length is 10 centimeters. So this is how probably the rod will be. This is the rod. This distance is 20. The length of the rod is 10. The focal point is 10. This is the focal point. Oh, you know what? If the focal point is 10, where is the center of curvature, my dear warriors? Quickly think and tell me. The center of curvature is right on the end of the rod. That means if an object is placed here, the image will be formed on the center of curvature. Remember the rules? A ray passing through the center will again pass back through the center. That's a very interesting. Okay. Now the question is, find the length of the image. A lot of you will be now tempted to use this formula. This formula, which we just did over here. Longitudinal magnification V by U. But remember this condition for small lens only, and look at the lens in this particular scenario. Look at the lens, 10, 20, 10, they are comparable. If this was not 10, this was 0.1, the rod's length, or 0.2 millimeters, then I could have used it. But now I can't. So I have no other option but to go by a very long method where I will treat the end points of the rod as point objects, and then I will find the respective images and then join those 2 points. Like for example, maybe this point, if I take it as object 1, maybe the image is formed here. If I take this point as object 2, maybe the image is formed over here. So in the first case, this was the object. In the next case, you will see this will be the length of the image. That's how you have to do the problem. Understood? You have to apply mirror formula 2 times. But thankfully, one good thing happened for me. One end is already on the center of curvature. So hence I know image 1 coincides with object 1 at center of curvature. That is the rule. That is a simple fact which we know for any mirror or concave mirror. The ray passing through the center will again pass back through the center. Distance is 1 by 4 length. 1 by V2, I don't know. Object, how far is this point from here? It is at a distance of 20. You can, no, 20 plus 10, which is 30, which is minus now because it is on the negative side. 10 plus 20 is 30. Is equal to 1 by focal length. Focal length is negative 10. Perfect. So 1 by V2 is equal to, take it on the other side, it will become 1 by 30 sorry, minus 1 by 10, which is basically 30, 1 minus 3, which is minus 2 by 30, which makes 1 by V2 as minus 1 by 15. So therefore V2 is negative 15 centimeters. Negative 15 centimeters means what? Center of curvature was here. This was at 20. Minus 15 means somewhere over here. This is where your other point is. This is where your other point is. And this distance is basically 15. So your final image will be formed between these 2 points. Will be formed between these 2 points. So what is the length of that image? What do you think is the length of the image, guys? This was 20 from C to P. So basically it is CP minus where that image number 2 is formed to the pole, which is 20 minus 15, which is basically 5 centimeters. Understood, guys? Everybody with me? Yep. Yes, the image is real. The image is real. It is 5 centimeters. Perfect. We got the answer. So it is diminished. You can see it is diminished. Earlier the object was 10, now it has become 5. So it has become diminished. So 100% it is a diminished image. It is a diminished image. That's how you solve problems when you can't use that formula. You have to apply mirror formula 2 times. Yes, the image was real. Perfect. How about going to a level 3 question also? Wow, JEE Advanced, where the object is moving. I think even the mirror might be also moving. Yes. And the question is, find the mirror velocity over here. Object velocity is given. Okay. Object distance, focal length, such that the image is at rest. Wow. The image is at rest is given. So object velocity is given. Find the mirror velocity. What a brilliant question. Let's go step by step to solve this question. There is no other option for this. First of all, what and all is given for me? Focal length, object distance, image distance is not given. This side is positive. This side is negative. This is our pole. Object distance is negative 30 technically. So if I use 1 by V plus 1 by U is 1 by F, which is mirror formula. Image distance do not know. Object distance negative 30. Object is on the negative side. Focal length is also on the negative side, so minus 10. So 1 by V is equal to 1 by 30 minus 1 by 10. LCM is 30, so 1 minus 3, which is minus 2 by 30, which is minus 1 by 15. So the image distance is basically minus 15 centimeters. Perfect. But that's not the end of the story. We have to find the mirror velocity. I know one thing. Velocity of the image upon velocity of the object is minus V by U whole square. But I'll tell you one catch. Here, this formula assumes the mirror is at rest. So, you ensure that the mirror is at rest by moving along with the mirror. So, you choose mirror as the frame of reference. So, this is velocity of the image with respect to the mirror, velocity of the object with respect to the mirror. So, I've changed the subscripts. That's the most critical step of this JEE Advanced 2022 problem. If you make a mistake there, then gone. So what is VIM? It is velocity of the image minus velocity of the mirror. What is VOM? It is velocity of the object minus velocity of the mirror. Is minus V is minus 15. Object distance minus 30 whole square. Clearly mentioned, the image is at rest. Mirror, my bad, image is at rest. That means VI is 0. VI is 0. So this is VM. Object velocity, clearly mentioned, 15 towards the mirror, towards the right side. So this is 15 minus VM. What is 15 by 30? It's half. Square it. becomes 1/4. So it will become negative 1/4. Lot of simple maths now. Okay, just take that negative negative, it will cancel. So it will become 4 times of Vm. 4 cross multiplies, negative negative cancels, is 15 minus Vm. Take Vm on this side, it will become 5 times of Vm is 15. So Vm is 15 by 5, which is 3 meters per second. So 3 meters per second, that is, or 3 centimeters, sorry, this was centimeters. 3 centimeters per second. That's the answer. Understood, guys? What a question, right? Loved it? Very good, very good. Now we'll start off with refraction, but after a small break. We'll start off with refraction after a small break. So let's return. Let's return. Now it is 7:40. Let's return at 8. 7:38. Yeah. Return at probably 7:55.
Hello, hello, hello. Good evening once again. I hope I'm audible and visible to all of you. Do let me know quickly in the chat box. Awesome, awesome. Okay. So let's begin with the next part of this particular lecture, guys, very quickly. Most likely we'll be just be able to do today plane surface refraction. We will probably continue with prisms in the next class, okay, which is part 2. Don't worry, we'll complete it. All right. So let's talk about refraction. Refraction, like I said, is the phenomenon which occurs when light goes from one medium to the other medium. And there are so many examples around you which showcase refraction or uses refraction for their application. Like when you put a pen or a straw inside the glass of water, it appears that it has been, cut and it has been bent and all of that. So this is because of the bending action of light. When the light goes from water to air, it will bend before it enters your eyes. So you feel that the straw is somewhere else. So this concept is based on refraction. So refraction is nothing but the bending of light because of the changes of the medium. Correct. Very good. And remember, when medium changes, even the speed of light changes. So if a light ray goes from a rare medium like air, rare is rare, it's not full of many molecules. It goes into a optically dense medium like water or glass. The speed reduces and the light ray bends towards the normal which is drawn at the interface. If it is going from dense to rare, it bends away from the normal and the speed will increase. Like if light goes from water to air, it will speed up and it will go away from the normal. This particular angle, which is made by the incident with the normal, is called angle of incidence. And with the normal, the refracted ray makes an angle called as the angle of refraction. It's called as the angle of refraction. Every medium has a unique property which is called as the refractive index. Just to give an example, even vacuum has a refractive index, and the vacuum's refractive index is 1. I know vacuum is nothing, basically nothing is there, not even air is there. That is, vacuum has a refractive index absolute of 1. If you use water, if you use glass, if you use plastic, if you use some diamond, some other translucent material, they have a refractive index depending on how much they bend the light, how much they slow down the light, and things like that. So, refraction is bending of light. Light changes the speed, light changes the direction, and the medium has a unique property called as the refractive index, which decides how much it will bend and how much will the light slow down. For vacuum, the refractive index absolutely is 1. Another example of refraction of light is how you actually see the sun even after sunset because of the bending of light from vacuum to air. Naresh, Ekalavya year-long test series syllabus, I'll definitely probably put it up on the Telegram or on the community. Okay, don't worry. Hi, Supreme Soy. All right. Yes, Rockstar, your Captain America. Okay, is back. Hi, Nageshwar. All right. So don't worry, test series syllabus, I'll put it up on the community. Okay, or probably on the Telegram group. I'll get it done. How come you are able to see the sunset even after the sun has actually set below? It's below the horizon, but still you feel that the sun is here. It's because when light goes from vacuum to air, air is having some matter as compared to vacuum. So air has a slightly different refractive index as compared to vacuum. Vacuum has a refractive index of 1. Air has a refractive index of 1.000 some 28, something like that. See, because of which the light bends and you are able to see it. Just to show you a simple diagram right over here, imagine this is the Pandu who is standing on the earth or somewhere over here. The sun is actually over here, which is basically the true position, of the sun. The light from vacuum enters the atmosphere, and if you draw a normal, this is the angle of incidence, it will bend towards the normal, which is angle of refraction mentioned here. So it will slightly bend this way, because of which you will feel that by the time this ray enters the human eye, it is coming from here and not from here. So if you extend that line backwards, you feel that the sun is here. So actually speaking, the sun has already set, it's below your horizon. The sun is below the horizon, but you feel that the sun is above the horizon only because of the bending action of light from vacuum to the atmosphere. Atmosphere also has some kind of refractive index. Hello, Aruna. Good evening, my dear warriors, my dear lions. Okay, till this point, everybody clear? So now many of you will be wondering, sir, how do I define the refractive index of any particular medium? Okay, how do I define the refractive index of any particular medium? What is it defined as? How is it defined as, guys? It is just defined as the speed of light upon the speed of light in that medium. Very simple. It is the speed of light in vacuum upon the speed of light in that particular medium, which is basically V. As simple as that. Just to give you an example, see guys, speed of light is having a value of 3 into 10 to the power 8 meters per second. Inside any medium, it will be much different. For water, refractive index of water is 1.33, which you often write it as 4 by 3. Refractive index of a normal glass is 1.5 around. Refractive index of diamond is approximately 2.4. Refractive index of air is roughly 1, which is like vacuum. So these are the absolute refractive indices of different medium, which is the speed of light upon speed of light in that medium. Very, very crucial. So I can also show it diagrammatically over here. If this is the interface, and this is the interface, the light which came had some wavelength and it entered with C. When it enters the denser medium, the speed will become V, but the frequency remains the same. Very, very crucial. Frequency of the light never changes. And I hope you know that the speed of light or speed of any wave is nothing but the wavelength multiplied by the frequency. So if the frequency of the wave does not change, or the light does not change, but the speed reduces, the wavelength will also reduce. So you will see that the wave which goes inside has even shorter wavelength, because the speed has reduced, the wavelength will also reduce. It will go with speed V. Okay, so this is what happens when a wave changes or light changes the medium. The wavelength changes, speed changes, frequency does not change. Till this point, is that clear? Yes. Till this point, is this clear? I hope this is absolutely clear. How to calculate thickness of an object? Aruna, that is a part of vernier caliper and micrometer screw gauge. You can check out my old classes. When we come to that topic, I will definitely let you know about it. But you can check my old lectures. I have explained how beautifully vernier and micrometer screw gauge works. Yes. Okay. User phone, I have already told you about. There is a separate video on how to join the Manthan batch on this channel. Just search for it, you will get it. Okay, if you want, leave a comment. Our team will reply to that comment with the YouTube link. Okay, cool. Now let's talk about the Snell's law, which is as simple as, if you have this as the interface, this is the normal. The light came from here with some speed, making some angle I, it went inside this medium with a speed v, making an angle r, then Snell observed the following, that the sine of the angle of incidence upon sine of the angle of refraction is the speed of light in that first medium upon speed of light in that particular new medium, speed of light in vacuum upon speed of light in that new medium. And remember, I just told you, C by V is nothing but mu. C by V is nothing but mu. So this is nothing but the refractive index of that medium with respect to vacuum. And whenever it is with respect to vacuum, you can skip that vacuum part. You can skip that vacuum part. You can just write it as refractive index of just that particular medium. It is just purely the refractive index of that particular medium. This is, in a simple way, I have written down the Snell's law. In a very simple way, I have written down the Snell's law. But if you want to write it in a more general manner, let's say this side of the medium, has a refractive index mu1, this side has refractive index mu2. The ray will come over here. This angle is I1. This particular angle is, let's say, I2. Okay, this speed is basically C1. This speed is basically C2. Then I can just write sine of I1 by sine of I2. Sine of I1 by sine of I2 will be C1 by C2, which is mu2 by mu1. This is very important. It is 2 by 1, not 1 by 2, which is also written down as 1 mu2. Light is going from 1 and 2. This is called as relative refractive index. Relative refractive index of number 2 with respect to number 1. Whereas what I have written over here, those are absolute refractive indices. They are absolute refractive indices. Very, very crucial. You can also see that we can cross multiply both of them. And if I multiply it, I will also get mu1 sine I1 will be mu2 sine of I2, which also means that by chance, if there were more mediums or more layers, and if the light which is coming in, it entered like this, then it bent like this, then again probably bent like this, bent there, something like that. You had refractive index mu1, mu2, mu3, so on and so forth. This is I1, this is I2. If this is I2, this will be I2. Then let's say this is angle in medium 3. This will be also I3. Then this is I4 in medium number 4. Because medium 1 refractive index into sine of the angle in that medium is constant, I can therefore extend it. In general, mu1 sine I1 is equal to mu2 sine I2, which is equal to mu3 sine I3, which is also equal to mu3 sine mu4 sine I4, and so on and so forth. In general, mu n sine of In is just a constant. This is what you get from Snell's law. Absolute refractive index into sine of the angle made in that medium is just a constant for multiple layer problems. This is what you get. Okay, very straightforward. I'll just repeat. Sine I1 multiplied by multiplied by mu1 is mu2 multiplied by sine I2. I cross multiplied. This was between any two adjacent layers. But if the light ray is going between multiple mediums, then you can extend this law to multiple mediums by multiplying refractive index into sine of that angle made inside that medium. As simple as that. Not just that, you will also see one more thing, Speed of light, just explained before, is wavelength into frequency. Speed of light is wavelength into frequency. So frequency will get cancelled. So this will be lambda 1 by lambda 2. Remember, it's the frequency, which has just got cancelled. Okay, I don't want this. Is the frequency which has just got cancelled. It will be wavelength 1 by wavelength number 2. Cool? Understood till this point? Yep. Why not sine? Why sine? Why not cos? Well, there is a derivation for that using two different ways. One is called as the Fermat's principle. The second one is basically using Huygens wave theory. So using Huygens wave theory, you get sine and not cos. So you might be wondering why that? Why not tan then? Or why not sine square? There is a derivation for that. Also, there is something called as the Fermat's rule, which says that between any 2 points, the shortest time taken is by the light. And when you use maxima minima function between those 2 points and derive it, you will get it as a sine ratio, not as anything else. Okay, so that's the reason behind it. I hope that is clear. There is a derivation which we don't have. Everyone, cool? Okay. Great, great. We can extend this even further. We just saw 1 mu2 is mu2 by mu1. And if it was 2 mu1, light was going from 2 to 1, then it would be mu1 by mu2. Therefore, 1 mu2 will be reciprocal of 2 mu1. This is also a very important and simple result. Very, very straightforward. Correct? Reciprocal. If you flip the manner in which the light is going, whether air to water or water to air, it will be reciprocal of each other. Next important thing, if I write 1 mu2, which is mu2 by mu1, I can just write it as mu2 divided by mu1 here, and I can put some number like mu3 here and mu3 here so that equality is preserved. What is this number, mu2 by mu3? Mu2 by mu3 is nothing but mu. Light has gone from where to where? It has started from basically 3 and gone to 2, from 3 to 2. What is this? This is nothing but mu. It has gone from 1 to 3. It has gone from basically 1 to 3. Exactly. I've just preserved the equality, nothing more, nothing less. I'll just do one small change before going ahead. Let me just bring it here. Let me just bring this here. It means this, I'll bring it here. Mu3 by mu1 is 1 mu3. Mu2 by mu3, mu2 by mu3 is mu3 2. Right? Okay. Now, this is basically called as the chain rule, chain rule of refractive indices. Notice how this is 1, this is 1. Okay, this 1 is here. Also notice how this 2 is here, how this 2 is here. So, in general, you want to start off with something and you want to end with that another medium. What you do is basically you write it as equal to, you start with that medium, in between you have as many mediums as possible or whatever you need, but you end it with the same medium. So maybe you can go from this medium to some another medium, then from that you can go to some another medium, then go to some another medium, go to some other medium, then go to some another medium, but end it with the end variable. That is chain rule. You can see there is a link of chain which is formed. 1 to 2 I want to go, you go to from 1 to 3, 3 to 2, or 3 to 4, 4 to 5, 5 to 6, 6 to 7, and end at 2, so 7 to 2. That's how it goes. That's why it is called as a chain rule. Is that absolutely clear, my dear students, how this works? Yes, I see, Kerala, I changed the thumbnail peak finally. Yep. Okay, it took some time, I don't know why. Yeah, so this is used for for finding refractive index of any medium with respect to any other random medium. So that is why I'll just block this off just in case you want to remember it. So all these formulas are very, very critical, whatever we learned just now. Refractive index is speed of light upon speed of light in that medium. Then you also have relative refractive indices, which is 1 mu2, which is defined as mu2 by mu1 standard, which is just mentioned right over here. It is called as refractive index of 2 with 1, but light is going from 1 to 2, mind that. And in general, mu into sine I is constant for any layer when light is going. Also, reciprocal formula when you interchange the terms, and the chain rule. These are the most important formulas. Okay. Now, well, one thing which we have already discussed this refraction from rare to dense will be going from dense to rare as a separate case. You will see why. So when light goes from rare medium to dense medium, from rare medium to dense medium, if this is angle of incidence, this is angle of refraction. Angle of refraction is less than angle of incidence, number one. If I call this speed of light c1, this is speed of light c2, then you will also notice speed of light in number 2 is less than speed of light in number 1 because this is denser. Also, the wavelength in 1 will be more than wavelength in 2, but frequency wise they will be same. Remember, c is f lambda, c is f times of lambda. If c is more, lambda is also more. That's how they go. Okay, so this is something which you should know. Also, lastly, I can say refractive index of 1 is less than refractive index of 2. This is dense medium. This is your rare medium. This is rare. This is dense. This is number 1. This is number 2. Okay, so this is something which you can easily interpret if you understand the fundamentals, that okay, it is going to denser medium, it is going to become slower, it's going to bend towards the normal. Okay, the wavelength is also going to reduce, frequency never changes. Okay, it is dense, that's why the refractive index is more. So that's how you can logically interpret it. You don't have to by heart any of these things, right? You don't have to really by heart any of these things. Let's solve some questions. This is there in Tattva. The refractive index of water with respect to air and glass with respect to air, refractive index of water with respect to glass is asked. We have been asked refractive index of water with respect to glass. Mu W G, that is what is asked. So that is mu. Remember, the first alphabet is G. Let me go to air first, multiplied by refractive index of air in between. You have to end with W using chain rule. I'm just using chain rule because I want to change the medium relative to each other. That's when we use our chain rule. First is first, last is last. In between, you can build your chain as long as you want. That is the logic. What do I know? Refractive index of water with respect to air. Yes, refractive index of glass with respect to air is given. So this is A mu W upon, this is reciprocal of mu G, and then there is A. Now this value is given. Water's refractive index is 4 by 3. Glass refractive index is 3 by 2. That will multiply 4 into 2 times. This will multiply 3 into 3 times. So this will be 8 by 9. So 8 by 9 is option B. Why have they put 9 by 8? It should be option B, refractive index of water with respect to glass. So refractive index of water divided by refractive index of glass. So it should be 8 by 9, guys. 8 by 9 is the correct answer. 8 by 9 is the correct answer. Yep. No, it is not D. It is not D. It is option B. Cool. Till this point, everything clear. Can we go ahead to the next question, my dear warriors? Here comes the next question. Light travels with some speed in crown glass, some refractive index. What is the speed of light in dense glass of refractive index 1.8? Interesting. In some glass, this is the speed. In some another glass, what is the speed? Remember, refractive index in general was C by V. So if I just do mu1 by mu2, what should I get? I will get V1 here, I will get V2 here. That's all. So refractive index of crown glass was 1.5. Refractive index of some dense glass was 1.8. In that crown glass, the speed was 2 into 10 to the power 8. In that dense glass, what is that speed is what I don't know. So just cross multiply and you are going to get the answer. V2 will be nothing but 15 by 18. Take that 2 into 10 to the power 8 on the other side. Understood, my dear warriors? Till this point, is it clear? Naresh, what you don't want me to forget? Let me know in the chat box. Just saying, don't forget what. Yep. So guys, this will go with this 9 times. 9 divided by 3 is 3. 15 divided by 3 is 5. So you just get it as 5 by 3, which is 1.66, which is 1.67 recurring. So into 10 to the power 8 meters per second. Let's find out. Yes, that is the correct answer. Understood? Straightforward. Yep, option B, correcto. Very good. Moving on to the next question on your screen. Ray of light is refracted at 37 degrees from air. Find the angle by which the ray was deviated. Interesting. Let's think about this problem. This is the interface. This is the normal. The light is entering at 37 degrees from air into water. Okay. So basically, let's say in water, from a ray is refracted at an angle of 37. Oh, the angle of refraction is 37 degrees. Okay. So this is basically 37 degrees, which is your angle of refraction. Okay. This is what it is. This was air and this was water. Ideally, the ray would have just traveled off like this. This was the intended path of the light, but it shifted by some angle. You have to find the deviation. One thing is clear, this whole angle is angle of incidence. If this angle is angle of incidence, that also means this whole angle, which is also equal to this angle, will also be the angle of incidence. So hence, this much angle which you see is the angle of deviation. So can you notice, guys, what is the angle of deviation now? The angle of deviation is angle of incidence minus angle of refraction, but I can be more or less than r depending on who is big or who is less. So this is the correct formula to find the deviation for refraction. This is the correct formula for finding the deviation for refraction. Why did I put mod? Because sometimes I is more than r, sometimes I is less than r. So we just want the positive value. That's why we put modulus. So this angle was I, opposite angles is also I. This whole was I, this was r. So the remaining will be I minus r. That is the angle of deviation. Yep, very good. Awesome. Okay. Now, what is next? What is next? You need to find out what is I. So we'll use Snell's law. According to Snell's law, sine of I by sine of r is refractive index. So sine of I by sine of r, what is r? Sine of 37. What is refractive index? That's 4 by 3. Okay, so what do I get sine of I as? Sine 37. That's basically 3 by 5 multiplied by 4 by 3. 3 cancels. So it will become 4 by 5. Whose sine is 4 by 5? That is 53 degrees. Oh, perfect. So we can find the deviation. So deviation will be 53 degrees minus 37 degrees, which is how much? Is 16 degrees. So the deviation is 16 degrees. Let's find out. Yes, that is the answer. 16 degrees. Straightforward. So such kind of questions can also come. Yeah, you just have to use Snell's law after that. So use Snell's law after this. So this is also a very important formula for finding deviation. Okay. Now let's go to the main part of refraction, which is going from dense to rare. And very interesting thing happens when you go from dense to rare medium. See guys, the light will bend away from the normal. The light will bend away from the normal. So if this is the normal, let's say the light was incident at a small angle like this. Let's say the light was incident at a small angle like this. It will bend away from the normal, maybe like this. Let's say the light was incident at a slightly more angle like this. It will bend even at more angle, probably like this. Then imagine I make the light fall at even more angle. It will bend even more away from the normal, and now it has just almost become parallel to the interface like this. This is the most critical scenario when the light which is emerging out has almost become grazing. Grazing means almost touching to the interface. Then this particular angle is basically called as the critical angle. Why? I'll tell you. See, before this dark green line, this was the incident ray. This was the incident ray. A part of the light was coming out. Not just that, you will also see a part of it also getting reflected. A part of it also getting reflected. When you increase the angle even more, this incident light will cause some refraction for sure, but at the same time, a part of it will also again reflect back inside the medium itself. Here comes the most critical part. At this particular angle, yes, that light is grazing and it is coming out. You will see most of the light will be just reflected at this point, because after this, if light is incident on it, if light is incident on it, it can't refract outside. So the only thing it can do, it will just reflect inside. There is nothing which is going to come out after this. There is nothing which is going to come out after this. So now it is totally reflected inside. Sometimes it is also called as total internal reflection, TIR, total internal reflection. Till this point, it was partially reflected. It was partially reflected, and you can see it was partially coming out. So it was partially refracted, partially refracted outside. But after this critical angle, it can't increase more. So all the light reflects back inside. This behaves like a mirror. So you can see this angle, whatever you see over here, okay, this angle will exactly match this angle. All the laws of reflection are valid now. Very, very important formula, very, very important concept. This is used many places. We'll come to that. Can you find this critical angle of incidence? Can you find this critical angle of incidence? Definitely we can find it out. It's very straightforward. I'll tell you. Imagine this medium is the denser medium. This is basically the rarer medium. Because I'm going from dense to rare, so I'll write it like this. D mu r, I'm going from dense to rare. That will be equal to sine of angle of incidence, which is sine of IC, divided by sine of angle of refraction, which is sine of 90. Why 90? Notice this is the angle of incidence. It has refracted at 90 degrees. It has refracted at 90 degrees. I have gone from D to R. So this will just become sine of IC. Sine 90 is 1. What is this? Mu dr. It is mu r by mu d. Usually, this is not what is given to you. This is not what is given to you. What is given to you is refractive index of dense medium with rare medium. Nobody gives you refractive index of air with respect to glass. They'll give you glass with respect to air. This is what is given to you. Hence, the formula for the sign of the critical angle will be nothing but 1 by refractive index of the dense medium with respect to the rare medium. Dense medium with respect to the rare medium. This is the formula which you are going to use. Is this absolutely clear? Very good. Excellent. Awesome. There are many effects which are based on critical angle, like this one over here, looming. So what happens is, if the atmosphere is such that below it is dense, above it is rare, imagine there is a distant ship, and the light rays from here are coming like this. Because the light is going in denser to rare medium, it will bend away from the normal. So if this is dense, this is rare, you will see it will bend away from the normal like this. And as it goes from one layer to the other layer, it will bend more and more away from the normal. That is why you are seeing that the light ray is bending like this. There comes a point when that angle of incidence matches the critical angle. So it no longer can refract, but it will get reflected. So you can see there comes a point over here somewhere where total internal reflection happens and it starts going down. So the light enters the human eye at an angle like this. So this person thinks that the light is coming from here. So he feels that the ship is floating in air. This effect is called as looming. This effect is basically called as looming. Okay, very, very interesting phenomenon. Let's see if you guys can solve this question. Critical angle for the liquid is 45 degree. What is the refractive index? Simple, guys. Come on. Sine of the critical angle is 1 by mu. So sine of 45 is 1 by mu. Sine 45 is 1 by root 2. Hence mu is root 2, which is 1.414. That is the refractive index. So you can also notice one more thing, that if the refractive index is higher, the critical angle is lower. That means easily it will get reflected inside. So diamond has a very high refractive index. So the critical angle is very low, meaning the light has a greater chance of reflecting inside because critical angle is small. Most likely, most of the times, the light will be incident at a large angle, so it will end up reflecting inside. That is why diamond will shine, because of high refractive index. Okay, this is done. Let's go to the next question. There is a bulb which is placed at the bottom of a tank containing water at certain depth. Refractive index is given. The surface of the water through which the light from the bulb will emerge is in terms of pi. What is the value of that multiplication factor? I'll explain this question. See, this is the water surface, and below it, you have placed a bulb somewhere over here. You have placed a bulb somewhere over here. Now the light from the bulb will come out at different angles. It will travel in all the directions. Like one light will travel here, it will go out like this. Dense to rare, so bending away. Again, come here and dense to rare, so it will bend away from the normal. Dense to rare, again bend away from the normal. But then comes the critical angle. When you reach far away, when you reach somewhere, when you reach somewhere far away, then there is a good chance you reach a critical angle. After this, the light won't come out. After this, the light won't come out. So all the light which reaches even here, you will see that it will just internally get reflected. All the light which reaches here will just get internally reflected. That's it. It is just getting wasted. It is just getting internally reflected. So only there is a point till which the light emerges out. There is a point till which the light emerges out. This depth is basically h. Now, this not only happens here, but throughout the surface of water. Just imagine this for a moment. Imagine this in 3 dimension. This is your water surface. This is your water surface. Your bulb is somewhere here. Your bulb is somewhere here at some depth. Your light is coming out from all the different places over here, and it will happen in a form of a circle. It will happen in a form of a circle. Just visualize this for a moment. Beyond this circle, you will not see the light coming out. The light will only come out from this particular region. Beyond this circle, the light will not come out. That is why the question has the value pi in it, because the area of that patch from which the light will emerge will be circular in nature. In fact, the radius of this circle will be r as shown over here. Do you see that? The radius of the circle will be just what I have shown over here. That's it, guys. So, what can we do now? Okay, let's draw a perpendicular. 100%, this is the critical angle. These two lines are parallel. So, even this angle which you see over here is the critical angle. So, therefore, what I can do is I can say tan of IC is basically R by H, and also sine of IC is 1 by mu. These are the only two equations which are needed to solve the question. So let's use that. Do I know the critical angle? I think so. We can find it out. Sine of IC is 1 by mu, which is 1 by 4 by 3, which is 3 by 4 over here. That is sine of IC. That is basically sine of IC. But I think we have to find the radius. Okay, so here is what I'll do. I'll just construct a small triangle. Don't think it is 37. No, 3 by 5 angle is 37. This is not 3 by 5. This is 3 by 4. This is 3. This is 4. 4 square is 16. 16 minus 9 is 7. So this is root 7. So this is basically your IC. So I will need it because in the next step, I'm going to write tan of IC. I'm going to write tan of IC. Where is it? R by H. Tan of IC is a radius by H. Tan is 3 by root 7, and that is a radius, which I don't know. Height or the depth is root 7. Root 7. Perfect. So basically R is nothing but 3. So therefore, area which is pi r square will be pi into 3 square, which is 9 pi. So hence the answer will be 9 pi meters square. Answer is 9 pi meters square. As simple as that. What a beautiful question. Okay. Yes, Saika, this is useful for droppers as well. Definitely. Arihant PYQ versus Oswald PYQ, I would say go with Arihant PYQ. Usually, I mean, both are fine. Doesn't matter. It's almost similar only. But usually go with Arihant. Okay. Fair enough. Can we go ahead to the next few questions, guys, coming up on your screen? Awesome. Awesome. So very, very nice question, which was based on this concept of critical angle. Very, very important concept. All right, cool. Let's go to the next question, which is going to come up on your screen. I think next is just, oh yeah, we have to go to lateral shift and then we'll go to longitudinal shift. These are the two concepts which we'll cover today, and then we'll continue the remaining in the next class. We'll do prisms in the next class. Lateral shift, very interesting concept, guys. See, I'll tell you what it is. Imagine you are given a glass slab, okay, and imagine some light ray enters the glass slab from some face, and if I draw a normal over here, you can see it is making some angle of incidence with this surface. Glass is denser, so it will bend towards the normal. So the light which is entering inside this particular medium, you will see that you'll see that it will probably bend towards the normal like this. Okay, it will just bend towards the normal like this. Again, over there, I can just draw another normal. I can just draw another normal. And now it is again entering the rare medium. So again, it will bend away from the normal. In fact, because of symmetry, guys, very simple thing. If this is angle I, this is angle R, this is also angle R, this angle will be back to I because air, glass, air. Eventually, I entered in air medium, so I have to have the same angle by symmetry. You can also use reversibility principle of light. If light entered from here, it will refract by R. So if light entered at R, it should refract at I. If light entered at I, refract at R, light refracted at R, incident at R, it should refract at I. Reversibility also can be used. Interesting thing to note is that if you extend this original line in which the light was traveling, you will see that the final ray is shifted by some amount. That is called as laterally shifting. So when you observe something, it feels it's off by some amount when you observe it through a glass slab, and it also depends on the thickness of the glass slab and stuff like that. Okay, so this particular distance which you see over here is basically your lateral shift. This is basically your lateral shift. I can call it as S, or I can just call it as delta. I can just call it as delta. Okay, as simple as that. Now, if you want to find this delta, you can use simple geometry to find this particular delta. You just have to use trigonometric ratios to find how much this particular delta is. Okay, you just have to use basically trigonometric ratios to find how much this delta is. Basically, you use one triangle over here, and then you use one big triangle over here, and then you find trigonometric ratios. I can show that to you. It is not that difficult. I'll just probably create a duplicate of it. So what you do is assume the thickness of the slab to be T, assume the refractive index to be mu. Look at this triangle over here, which is having the base T. Then this is the other face, this face, and this green line over here. This green line over here. Okay. So in this particular case, you can easily see this is basically angle R. So this is basically your hypotenuse. So if I use cos R ratio, it will be T divided by hypotenuse. Just keep it aside. Don't do anything. Now look at another triangle over here. Look at this particular triangle, this side, the green one. Then this dotted blue line, and then this, which is delta. If this is I, this is R, how much will this angle be? Think about it. Think about it. This is I, this whole will be I, this is R, this will be I minus R. Just check this out. This will be I minus R, that angle. So this angle over here is I minus R. Okay, perfect. And this is nothing but your hypotenuse, is your hypotenuse. So in this particular triangle, this is 90 degree. This is basically 90 degree. So again, I can say sine of I minus R is opposite side by hypotenuse. Opposite side by your hypotenuse. Opposite side is delta. But hypotenuse, I know from here also. Hypotenuse, I already know from here. How much is it? It is T divided by cos R. T divided by cos R. So just substitute that over here. So therefore, our delta will be nothing but sine of I minus R multiplied by hypotenuse. Therefore, delta will be sine of I minus R. Hypotenuse is T by cos R. So multiplied by T, the whole thing divided by cos of R. That is the formula. This is one formula which you are supposed to remember. In fact, I'll put it on the next slide. The next slide, the delta will be thickness divided by sine of I minus R. Sorry, delta is equal to T divided by cos of R, and this is sine of I minus R. What is thickness? This one. This is refractive index. Okay, very, very important formula. Very, very important formula, guys, which I have derived for all of you. Cool. Let's see some questions based on it. Let's see some questions which are based on it coming up on your screen. This was asked in JEE Mains 2022. Very straightforward. For the lateral shift of light ray when it passes through a parallel slab in air, the angle of incidence is 60, angle of refraction is 45. What is the lateral shift? Very straightforward. Delta is T into sine I minus R by cos R. What is the thickness? The thickness is 10. What is the angle of incidence? Angle of incidence 60. What is angle of refraction? It is 45. Whole thing divided by your cos of 45. Okay, so this will be 10. 60 minus 45 is 15. So 10 sine 15 degrees. Cos 45 is 1 by root 2. So this will be 10 root 2 sine of 15 degrees. 10 root 2 sine 15 degrees, which is option number A. Very straightforward. This was asked in JEE Mains. Wow. So nice. Straightforward, right? Okay. Let's move on to another question maybe. Light rays incident on a slab, refractive index, incidence is critical angle for the glass slab. The lateral displacement is how much? Wow, they have combined some two concepts, three concepts together. So the angle of incidence is the critical angle. Angle of incidence is the critical angle, and we know sine of critical angle is 1 by mu, refractive index being root 2. Therefore, that implies critical angle is 45 degree. Therefore, angle of incidence is 45 degree. That is the first thing which we get from here. We also need angle of refraction. So we use Snell's law. So sine of I by sine of R is mu. So sine of 45 by sine of R is refractive index. How much is the refractive index? It is root 2. So from this, 1 by root 2 times sine of R is root 2. So sine of R, root 2 into root 2 is 2. So it will become 1 by 2. That means R is basically 30 degree. Okay. I got R. I think we can now solve the problem for delta. So it is thickness sine I minus R by cos of R. What is the thickness? 4 root 3. What is sine of I minus R? I is 45. R is 30. Okay. The whole thing divided by cos of R. What is R? 30. Perfect. So this will become 4 root 3. Cos 30 is root 3 by 2. So 2 goes on the top. Sine 45 minus 30 is 15 degree. Sine 15 is 0.25, which is 1 by 4. So this will be 1 by 4. Root 3, 4 cancels. So the answer will be 2. The answer will be basically a big fat 2. Yes, that is the answer. Okay, so these kind of questions do come in the JEE Mains or JEE examination. Very nice. Now, the last part in this is something called as the lateral shift, or sorry, longitudinal shift, where you are seeing an object, it appears closer or farther because of refraction. Like you see the bottom of a tank, it appears that it is closer to the water surface. If you are a fish looking outside, the sky will appear even farther. That's what happens if you are a fish, you are inside water. This is the concept of your apparent depth or apparent height, which happens because of your refraction phenomena. So usually this is your apparent depth or apparent height. apparent depth, and this whole thing which is there, complete thing, is the actual depth or height. Actual depth or actual height. There is a relation between the two. It is very, very straightforward. So I will just show that to you. I'll just show that to you. If you are an observer in the rare medium, looking at an object in dense medium, the object comes closer. The object comes closer to you, and you will see the image is closer than the object. And if you are an observer in the dense medium, looking at an object in rare medium, like a fish seeing a bird, the object goes far away like this. Okay. If I mark the heights and all of that, okay, so this will be H apparent, and of course this will be H actual, this will be H actual, and this will be H apparent. Here the apparent height is smaller than the actual height, so it is actual height divided by the refractive index. Here the apparent height is more, so the apparent height is mu times the actual height. That's how easy it is to remember the formulas for apparent and actual. For apparent and actual. Okay, for both the cases, whether you are in dense medium or whether you are in rare medium, both the cases, either you divide by mu or multiply by mu, depending on whether you should be close or whether you should be far away. Very, very straightforward. Very, very straightforward, my dear warriors. Okay, now using this concept, you can find out in a glass slab how much shift occurs. Imagine you are seeing through a glass slab. Imagine you are seeing through a glass slab. This is the thickness T. This is refractive index mu. Here is the observer. What that observer will see is that if there was an object here, that object will come closer towards you and the image will be formed here, which means the entire world behind whatever is there here will come closer by the same amount. You will see that the image will be formed over here. This is, you are basically shift longitudinally which is happening because of a slab. This is that shift which is happening over here, which is the same as the shift which is happening here. This delta, you can think of it like this. Think of it like this. This is your actual depth. This is your actual depth from this surface. This is basically your apparent depth. So this delta is actual minus apparent depth. Actual depth is T. What is apparent? Apparent is less. So it is actual by refractive index. It is actual by refractive index. You can use that. So hence you will get the value of delta as P common 1 minus 1 by mu. So whenever you observe through a glass slab, you will see the entire world behind it shifted by certain amount. Yep. I hope this is absolutely very clear. There are many simple questions on this. We can start doing some questions. A coin is placed at the bottom of the beaker. Height is 10. Refractive index is given. Find the apparent depth of the coin. So there is a beaker over here and there is a coin somewhere, which is the object. The image will be seen here. Question is find the apparent depth. It is clearly mentioned the actual depth is how much? 10 centimeters. 10 centimeters, and we have to find what is this. So we know apparent depth is actual. This is smaller, so I will divide by mu. So it is 10 divided by refractive index, which is 4 by 3. 10 by 4 is 5 by 2 into 3. So this is 15 by 2, which is 7.5 centimeters. So answer is, 7.5 it should be. Yeah, not 2.5. It is 7.5 centimeters. Correct. Very good. Is that clear, my dear warriors? My dear lions? Okay, this is how you can do it. Yep. Moving on to the next question. I think the answer over here given was wrong. Let me just delete it. Okay. This is, I think, reverse question. Bird is flying. A fish is seen. So where will that fish see the bird? Where will that fish see the bird? So the object is at a height of 3.6 meters. Uh, you will see that the bird will be somewhere here, image wise. Okay. So the apparent height will be actual height multiplied by mu. Actual height is 3.6, mu is 4 by 3. 3.6 by 3 is 1.2 multiplied by 4, which is 4.8 meters. All this is from the surface. All this is from the surface. The apparent height of the bird to the fish. If you add the fish, if you add the fish's depth also, the fish is over here, which is at a depth of 1.2 meters. So then you add 1.2 to it, which will become 6 meters from the fish. From the fish, it is 6 meters. From the surface, it is 4.8 meters. So 6 from the fish and 4.8 from the surface. As simple as that. Correct, my dear warriors, lions, understanding it? Very, very straightforward questions are asked. You can see this is a JEE mains question. Hopefully, yeah, we will be able to solve it. The vessel of depth D is filled half with oil of some refractive index and half with water. What is the apparent depth of this vessel? Interesting. So we have this vessel and half of it is, let's say D by 2 is some refractive index N1 and the other half D by 2 is refractive index N2. So if you place an object here, it will appear closer. The image will be formed here. The total depth was D. Question is, how deep will that image look from the surface? How much is this H apparent? Very simple question. Normally, our apparent depth was H by mu. But when there are more glass slabs, one glass slab, second glass slab, third glass slab, etc., what you do is very simple, guys. H1 by mu1 plus H2 by mu2 plus H3 by mu3, like that. You just keep adding. That's all. In this case, there are only two glass slabs. Think of it like glass slabs, water layer, liquid layer, whatever. So it is D by 2 by N1 plus D by 2 by N2. So D by 2 is common. LCM will be N1, N2 by and N1, N2 over here. N1 plus N2 over here. So D by 2, N1 plus N2 upon N1, N2. That is basically your option number B. Straightforward. So when multiple layers are there, you just add them. You just add them. Okay? Very, very straightforward. Excellent. We can do one more question which was asked in JEE mains. Very, very straightforward, guys. Two immiscible liquids are there and they are put in a beaker. The height of each column is 6. Coin is placed from the bottom. At the bottom of the beaker, the apparent depth of the coin is how much? Same thing again, just repeated. You can see in JEE 2 times this question has been repeated. Same concept. So the apparent depth will be height, which is 6, by refractive index, which is 3 by 2, plus 6 divided by new refractive index, which is 8 by 5. Just using this formula. Just using this formula. Nothing more, nothing less. 6 by 3 is 2. So 2 into 2 plus 6 divided by 2, 3. 8 divided by 2, 4 multiplied by 5. So it will be 4 plus 15 by 4. Correct? Yeah, so it will be 16 plus 15, which is 31 divided by 4. So 31 divided by 4 is the answer. So the answer is 31. So the answer of alpha is basically 31. That's how the simple question is. So these are the kind of questions. Now we'll be starting off with prism later on. Okay, there is one more question which we can do. Yep. Find the apparent distance between the observer and the object shown in the figure and the shift in the position of the object. This is exactly this concept. You observe the world through the glass slab. The world appears closer by this amount, T into 1 minus 1 by mu. That's all. So T into So the shift is T into 1 minus 1 by mu. So thickness of the slab is 10. Mu is basically 2. So 10 into half, which is basically 5 centimeters. The shift in the position of the object will be basically 5 centimeters. And if you end up measuring from the observer, it will be 10 plus 10 plus 20 minus 5 is 15. That's it. That is what it will be. So which is nothing but 35 centimeters from the observer. 35 centimeters from the observer. So 5 centimeters towards the slab is the shift. 35 centimeters is the distance from the observer. Okay, great. So I think after this we are going to start with prism, but like I said, we'll do it in part 2 now, not right now. I had planned for it, but I don't think we will be able to do it today. No issues. Optical instruments, combination of lenses, everything, we'll do it in the second part. No issues. Okay, cool. So I hope you guys learned a lot in the part 1 of today's lecture. The PDF will be available in the Jungle Book as well as the Telegram channel. Join the Telegram channel, link is there here. Buy the Tattva book, link is again there in the description. Part 2 will happen on Friday. Okay, stay regular, stay focused, do not deviate. That's all I would say. Thank you so much. Captain Shreyas signing off. Hasta la vista.